Welcome to Microsoft Azure Training Days. I'm Andrew Whiteside. I'll be taking you through a series of 5 videos where we'll talk about deploying applications on Azure, data on Azure, and basically how Azure can help you build your cloud-native applications. So let's get started. This is the apps learning path, so it's the first in a series of 5. First of all, we're going to talk about how you can build your applications with APIs with cloud services in mind. So there's 5 different videos that I'll be talking through over the course of this series. There'll be a break after the third one. First one will be about building and running your app in the cloud. Second will be about options for data in the cloud, so what options Azure provides you to store your data. The third will be talking a bit more about containers, so talk about modernizing your application in containers. Then 4 and 5 will be moving into a bit more advanced topics about containers like Azure Kubernetes service, AKs, and then talking a little bit about monitoring, performance, and scaling. So let's move on to the first one. Okay, so during this 5 video series, we'll be using Tailwind Traders as a case study. So Tailwind Traders is just it's a sample company where they do e-commerce. It's kind of like your online kind of Bunnings where you can buy, power tools, stuff for your home, etc. So this will be a case study that we'll be talking through. They're going through sort of a massive period of growth. We're talking about options whether they can run their application on Azure. So we'll talk through technologies like VS Code, Azure Portal. I'll give a demo of what the Azure Portal looks like. We'll talk through using the Azure CLI and how you can deploy your applications into Azure and interact with those applications in Azure. Okay, so when it comes to developing in cloud, there's tons of different options. And none of them are bad choices, actually. So depending on the scale of your application, you might use different cloud-based tools. So for example, if it's a very large banking application, security might be your largest concern. So you might deploy using different tools to, say, a startup. So even though there's a plethora of options, like moving to cloud, sometimes it feels a little bit intimidating. When you open up a cloud dashboard and you see like, wow, there's so many different tools to choose from, like what exactly do I choose? The way to choose is to think about what your application needs to do right now and choose the right options. So I'll be running through a few different options on how you can build your applications in the cloud, deploy your applications on the cloud, and get them running in the cloud using Tailwind Traders as a reference. Okay, cool. So in this session, we'll be talking through 3 major topics. So one will be deployment tools. So tools for building your applications and tools for deploying your applications to cloud. Talking through deployment options, so different options that you can choose when deploying your applications to cloud. And we'll be talking a little bit about some basic security features. So when you're running an application, whether it's on-prem, in the cloud, or a mix of both, you probably want to put in some basic security features to make sure that you have peace of mind and you know that your application is secure. So we'll talk through the deployment stuff, tools for building, options, and security features. So these are the 3 topics that I'll be talking through today with further topics in further videos. Okay, so tools for cloud deployment. The first one I want to talk about is Visual Studio, right? So Visual Studio is the big IDE with all the bells and whistles. Definitely my favorite IDE, the best IDE in the world. I historically was kind of a .NET guy back in the day, so I've been using Visual Studio since about 2005. I think they've gone through, I think it's up to Visual Studio 2019 now, so there's been many, many versions. It's really the best IDE when it comes to if you want to debug your applications. They comes with a whole variety of different plugins. Even if I speak to, there's a guy that I work with called Chuck, he was telling me that Visual Studio is definitely the best IDE in the world. So let's have a look at a couple of the major sort of features of it. So it's multi-platform, so there's a version for Windows and Mac. it has all the separate modules you might need depending on what you're developing. So if you're developing a .NET application or a Node.js application or a Java application, it has different modules that you install into Visual Studio depending on what you're developing. So if it's mobile apps, or a Windows application, or a web-based application, there's different modules that you can install into Visual Studio, and they work. It's got support for all the programming languages under the sun, support for C#, F#, Java, JavaScript, all of the languages. And one of the most interesting things about Visual Studio I find is live share, right? So in this period now where everybody's kind of working from home, one of the cool things is, often you do video conference, right? So if I'm working with my colleagues and I'm having a problem, I'll call them using Teams, right? So with Visual Studio, when I call one of my colleagues, we can actually live share the Visual Studio instance so that you guys can actually work from the same terminal together. And that's super, super cool, especially for pair programming. So some of the teams that I work on, we do pair programming. So what we do is we have a call, and then we do the Visual Studio live share, and then actually it's two people working from the same Visual Studio instance, and you can code together. So that's really, really cool, built into Visual Studio. So it's kind of like pair programming natively, if that's the thing. So you can actually do pair programming remotely, which we used to do it in the office where we have two people at the same desk, but with Visual Studio we can do it remotely. So I'm a big fan of pair programming. I think that everybody, if you haven't tried pair programming, using Visual Studio is a good chance for you to try. Okay, another tool that you can use is Visual Studio Code. So VS Code is the lightweight version of Visual Studio, and it's probably the most popular text editor in the world, right? So it's completely open source, so it's Microsoft open source offering. It's got tons of community extensions, from like reformatting your code to theming the IDE itself, autocomplete, IntelliSense is amazing, deployment tools, etc. Me personally, one of my favorite tools is called Wallaby.js. So if you're working with Node.js or JavaScript, it actually provides a visual way that you can see code coverage for your unit tests. So if you've ever seen, one of those code coverage tools, basically for every line of code, it will show like red or green, red if there's a failing test, green if there's a passing test, or white if that test is not covered. So if you're doing unit testing as part of your team and you want to ensure a high level of code coverage, then I'd recommend using one of these tools. So, and that's just a community plugin, that somebody's written to make their life easier. So VS Code's got plenty of those. It also works on every system, so Mac, all your Linux distributions, Windows. Actually, it's not just for programmers. Like, I find that it's got nice formatting for your DevOps or your infrastructure guys. So there's a DevOps guy working with me here, and he uses it to look at his YAML files, right? So if you want to look at like a Kubernetes YAML file, it will give it a nice formatting for easy reading, right? So VS Code, if you're not already using it, I'll be surprised, but it's very, very cool. Also Terminal. So, if you're doing any programming and you want to sort of interact with the services running on your machine or interact with services running on Azure, you're probably familiar with some sort of terminal, either Windows command prompt or PowerShell or Linux terminal. The cool thing about Azure is that it provides you, and you can interface to Azure using the terminal, right? So there's three different ways, which I'll give a quick demo on that a little bit later. So one is the Cloud Shell. So you can actually, in the browser, you can browse, it has a virtual kind of command prompt, and in there you can interrogate what's running in Azure. There's also the CLI, which you can download to your machine. So I've downloaded the Azure CLI on my machine. I'll give a demo of that a little bit later on. And also, there's actually a built-in terminal into the Azure portal. So if you go to the Azure web portal and you can click on a little button, which I'll show you, you can actually open up a little CLI and you can interact with what's running in Azure. So that's kind of a quick summary of a few tools that you use to build your application. VS Code, if you've got the subscription, I think definitely go for that. If you're not already using VS Code, you probably use it for any sort of text editing or small kind of websites. If you're using if it's a very large enterprise application, I'd recommend Visual Studio. Okay, so here's a concept, right? So here's an Azure concept. An Azure concept is ARM templates. Right, so what are ARM templates, right? So ARM template is a definition of your infrastructure as code in JSON format, right? So let's say you've probably heard of the concept of infrastructure as code, right? So infrastructure as code means make sure that all of your infrastructure is clearly defined as code in YAML files, JSON files, etc., so that you can deploy it, it's repeatable, and there's a running sort of documentation of what's in your infrastructure. So, traditionally you might find like systems administrators go in when they're running up, maybe on-prem sort of VMs, they might go ahead and like configure VMs manually and do these kind of manual things. What we want to move away from that, right? We want people to move to running the infrastructure as code, making it deployable and repeatable, right? And it's also, you can version it and deploy. So ARM templates is the Azure flavor of that. So what you do is you define up in a schema all the different pieces that you want running in your infrastructure. So let's say a couple of virtual machines, or maybe a scale set, or maybe a database. You define that all out as JSON, and then you deploy it. You can deploy directly from that template into Azure. So that's actually very, very cool. It's nice to use. Probably something interesting is that you're probably not the first person to have to deploy a website or a 3-tiered website with a database, right? So in Azure, there's tons of quick start templates that you can use to deploy your solution. So let's say you're building out an IoT platform. So if you have a look on the Azure website, they have some sample templates which would deploy out kind of what you need for your standard IoT application, like a database, maybe an app service, maybe some file storage, etc. So if you have a look on, I think it's here. Right, so if you have a look here, if you go to aka.ms/azarm, there's a whole bunch of ARM templates that you can use to deploy sample infrastructure. So I think that, if you're starting to build a new application, or you're wanting to see what an application would look like in the cloud, I'd say go through here, say, okay, cool, I've got a shopping cart application, look at the template, it's made of a few things, you hit deploy, and it will deploy it into the cloud. So, if you look at it, it might be a little bit scary to look at it first, a whole bunch of sort of JSON, but rather than trying to write out that JSON yourself, if you're working with it, I'd say go to the Azure website, grab one of those templates that's already there, and add what's missing or change it. So definitely bookmark that address. I refer to it all the time. Okay, cool. So that was kind of a bit about build tools, tools that you would work with when you're deploying into Azure. The next section I'm going to talk about is where you can deploy. Right, so that was kind of like, okay, you use Visual Studio, use the terminal, use ARM templates when you're coding, when you're defining what it is that you're going to build. For Tailwind traders, they would come up, maybe there's a development team, they're using Visual Studio, they build, and then use an ARM template to deploy it into Azure. So the next section I'm going to talk about is where to deploy it, right? So if you're running on-prem, you might have VMs running on some hypervisor. So this is going to talk, right here I'm going to talk about where you would want to deploy your items in Azure. Okay, so first is like static websites. So one of the options is static websites. So you can actually just dump your whole application into an Azure blob storage. Now, Azure blob storage is just a folder living in the cloud. So it's just like having one folder in a file structure living up in the cloud. So if you've got a static website, which is just HTML pages, you can actually deploy it into Azure Blob and then just serve it from there, right? So If it's just a HTML page, as you know, if you open up a HTML page in your browser, it will open up as a website, right? So you can actually just dump all these HTML files into Azure Blob Storage, and Azure Blob Storage provides a reference to that file, and you open up that file, and it will just serve as an application. The interesting thing about this is that with React and Angular and other sort of JavaScript frameworks, you can actually build a static website, which is pretty elegant and complex, right? So you can actually, if you're looking for a cheap, fast, quick, easy way to deploy a website, and you don't need a web server, you can just create a Azure Blob Storage folder and just just deploy your files there. Yeah, it's super low cost because you're only paying for the folder up there. Super fast, but obviously if you need a database or you need something a little bit more complex, then it might not be suitable. But definitely it's a quick option for something quick and easy. Also, if you're looking into the future, there's something called Blazor, which allows you to run C# code in the browser. So that's kind of cool. So if you're looking at static websites or this kind of static website option, there's a lot more in the future of this space, I think. Okay, so the second option is web apps. Now, web apps is a hosted managed service in Azure where you can deploy your application to. So it's a platform as a service option. It's fully managed, and it provides. So rather than running your own virtual machine, let's say there's an option of you want to deploy your application to virtual machines, right? So you can spin up virtual machines in the cloud and deploy your application to those virtual machines. But the problem with that is you need to maintain those virtual machines, right? You need to make sure that they're up to date. You need to make sure that they don't crash. You need to make sure that any patches are done. Disaster recovery you need to take care of yourself. Scaling you need to take care of yourself, etc. So the web app offering allows you it abstracts all of that away from you. So underneath it is virtual machines, and it is running on virtual machines, but Microsoft sort of takes care of that for you. So you don't need to worry about the machine level stuff. You just need to worry about here's where you deploy your application, and it's running. Right? So it fully supports Linux and Windows, supports many languages, the .NET family, Java, PHP, Ruby, Python, Node.js. So you can deploy these type of applications just into this managed service, and it just runs. And I'll give a quick demo of that a little bit later as well. But I think it's cool, and there's some really cool features there because I think that managing your own machines is kind of grunt work, right? You don't want to do that. You want to just concentrate on writing your code, concentrate on deploying your application, concentrate on new features, and you don't want to have to spend your time fiddling with the details of the machine. So deploying into the app service is probably one of the better options. Okay, cool. So if your application is a little bit more advanced, there's a couple container offerings in Azure. So there's two options here. So one is ACI, Azure Container Instances. So basically what that is that you can deploy an individual container into the cloud. So let's say you have a stateless service, like a video encoding service or something. You can actually deploy that separately as its own little container running in the cloud, not attached to anything else, with its own little public IP, deploys in there, does some processing, can be accessed, etc. And it's super, super simple. It's like one command using the Azure CLI. You just say, I think it's AZ create ACI, and then it spins up a new instance for you. So that's super, super cool and super, super lightweight. I think it's built by the minute. And then the other offering is if you've got something a little bit more complex, a long-running application with stateful services, and you need to have high availability, you want to be able to scale the application, maybe it's connected to a database, you can go with Azure Kubernetes Service. So the Kubernetes offering is a more advanced offering, I would say, used for more sort of advanced applications. And ACI would be used to sort of supplement your existing application by running a couple containers. Yeah, so I think that's cool. In talks number 3 and 4, I'll talk more about containers, a little bit in detail on exactly what containers are, and in detail on AKS and how that works. So that'll be a little bit further in this series. So there's just a quick slide here. It will show you on some of the top scenarios for containers on Azure. So one would be, why would you want to move to containers, right? I mean, containers is a huge buzzword at the moment. People are all about, if you're not on containers, then why are you not? And you should be moving to containers. So there's a couple big scenarios here where it might be suitable to move to containers, right? So one is kind of cost saving. You want to save some money rather than running, large pieces of infrastructure. You could run just the individual containers. It's cheaper. Agility, so faster application deployment. If you're deploying individual containers, it doesn't come with the operating system overhead, so it deploys quickly. Performance is another one, so low latency processing. Containers are kind of more suitable for that kind of workload. Portability, so the cool thing about containers is that you can run the same, once you build a container, you can run that container on your machine, in Azure, in ACI, in Kubernetes, and it's the same thing running everywhere, right? So it's portable. And then also automation, right? So you can, with a lot of like Kubernetes itself, the deployment stuff is built in. So when you deploy a container, it will spin up and run faster, right? And I think, when it comes to software engineering, you want to be able to deploy your application fast. I think the faster you get your changes or your new features to market, the faster you get feedback, and then the faster you can work on new, more relevant features, right? So getting your code to market faster is really the biggest kind of end goal. And that's kind of what, if you watch some talks on DevOps, I give some talks on DevOps, that's kind of what DevOps is really all about. So containers can help you with that. Another option is virtual machines. So let's say, the application is already running, it's a legacy application, it's already running in VMs. We don't have time to move it to containers. Azure provides a VM option. So you can actually take your application that's running in VMs on-prem, you can spin up those VMs on Azure, and then instead of deploying to those on-prem ones, you deploy to Azure. That's it. Done. So virtual machines are tried, tested, they're a fantastic option. It's true that VMs require more care, but they also have some perks which make it pretty useful, right? So moving to containers is a reasonably large undertaking. So you need to look at the architecture of the application, you need to look at how to separate the application nicely. If you're looking to get to cloud fast, you probably want to go within, and you have an application that's already running on VMs, you probably want to look at lift and shifting to VMs first, and then evolve as we go. Okay, so this is something cool, right? So this image is showing shared image gallery, right? So what this means is, let's say you want to spin up VMs based on an image, right? So let's say, okay, I've got my application and I've got it all clean and running on a VM, and I go, okay, I want to be able to scale that application out, right? So I've got more usage, right? So what you can do is you can actually take an image of a running machine. So let's say you have a VM running in the cloud, it's all there. You actually there's literally one button, you click capture, and then it creates an image of that machine, and you can store that image inside your Azure portal. So once you have that image, you can actually use that image as a base for what's called a scale set. And a scale set is a set of VMs which will scale up based on that image, depending on demand, if you like. So let's say if you've got one virtual machine image and you go, okay, cool, during peak load, when, or Black Friday sales or whatever, you want it to scale up to 10 machines, you can set it so it automatically scale up to 10 machines based off that image. And then, when it's normal sort of processing period, it will scale down. So this image here is showing that if you have one VM image loaded into a shared image gallery, you can actually also you can scale it up. So let's say if you've got one image in the shared image gallery, you can scale it up to 2, 3, 4, 5 replicas of that image for redundancy and whatnot. So if you scale up to 5, you can actually build up to 20 VMs based off one image. So if you scale the image up to 5, you can actually have 100 VMs running in Azure just by clicking a couple of buttons. And you can set it so that they run in different regions to process different workloads, right? So you could have some running in the region, Southeast Asia, and some running in UK, some running in US, etc. So that's actually really, really cool. And I'm gonna demo that in a second. Okay, cool. So here's the demo part. I want to show you guys how to create a VM. So this is how easy it is. Actually, and I'm going to create a scale set. Okay, so my screen here shows the Azure portal. So if you haven't seen the Azure portal, this is kind of what it looks like. I'm going to go to one resource group, which I had before. Resource groups is just a container of where you will hold your cloud services. So what was I going to do? I was going to create a scale set. Okay, so creating a scale set, actually creating anything is just a matter of going add, and you can choose from any of these items in the Azure portal, right? So if you wanted to create a virtual machine, it's just as easy as this. So if you want to create a virtual machine, you can create a virtual machine. But what I'm going to do is I'm going to create a virtual machine scale set. Okay, so the scale set is what I talked about. So you can have one image and have many machines that scale based off that, right? So here we go. Create one. Right, so I'm just going to call it maybe Tailwind website. So Tailwind website scale set. Now, the image. So I was talking about image just a minute ago. So when you are scaling out a scale set, you need to choose what image it's going to be. So there's a whole bunch of images here provided straight out of the box from Azure. Like you might want to have a base Linux image or a Windows Server image, etc. But what I was talking about before was having your own image of your application that you use to create the scale set from. Right? So if I go to browse here, I can select from my images, and I've already got one that I created here. So I've created a golden image, which would be a snapshot of a particular VM. So I ran up a VM, got my application running, clicked capture, and then saved it into my images. So I've got my image here. If I select that, it's got the size here, which I chose before, and then there's you need to specify some authentication. So I think I've got some notes here. Okay, so I've got SSH key, and then that's just the SSH key from my machine. So you've got to review and create. You can actually specify a lot of stuff in here when I'm creating a scale set. You can do disks, networking, scaling, a lot of advanced options. But I'm just going with the defaults here and just creating here. Right, so this is using the Azure portal to create the virtual machine scale set. So there's actually a few other options here for when you're creating scale sets or when you're creating virtual machines in Azure. So you can see here the deployment's in progress. So I mentioned a minute ago that there's an integrated cloud shell. So over here, you can see there's an integrated cloud shell, which will just load up in a second. And then there's also the Azure cloud shell. So if you go to shell.azure.com, you can actually use the cloud shell to access your Azure portal, right? So this cloud shell is automatically logged in. It's the same login that I had over here. So you can use a couple, like if I go AZ, VM list, I can make it pretty as an output as table. So this will actually query my subscription. I don't have any VMs running at the moment. So, but you can see AZ VMs. Okay. So this is actually interacting with my portal here using my account. So the account that's logged in here. So that's one of the options for interacting with Azure. That's not the portal, right? So you've got the portal here. You can use the UI. There's also Cloud Shell here. There's also Cloud Shell built into the terminal, which I mentioned here. So I can go and list. Okay, so there's no VMs in there. And then also another option is, I mentioned before, is you can have the terminal, have the CLI deployed to your machine. So let me just make this much larger. So you have a list, right? So I think I've got some of this other subscription. Yeah, so this. So this one I just downloaded the CLI to my laptop, and on my laptop it's connected to. This one's actually connected to a different Azure account. This is one of my other Azure accounts, but here I've got a VM running there, and I can just run this command to list out my VM. You can also use the create command, which is cool. This is actually the command. It's because it doesn't have my resource group. That's okay, that's fine. But this is what the command would look like to create the scale set, not using the UI. So using the terminal, you can create the scale set the same way as I did it over here. There's a couple options as well with the CLI. There's a bash option and there's a PowerShell option. So if you prefer working with PowerShell, there's a PowerShell option which you can use to interact with your Azure services. There's also a bunch of documentation on how to do that. So heaps of documentation. I think I'll just find one here. So maybe Azure CLI documentation. If you check here, there's a whole bunch of code documentation, like this, I guess. So these are the different services that you can interact with using the CLI. Let's just get some samples so it looks like. It's creating a virtual machine, something like this, right? So you just go AZ VM create, plug all the stuff in, hit go, and then the VM will spin up in Azure. It's super, super cool. If you're looking at automating stuff rather than using the UI, you want to go to infrastructure as code, I recommend using the CLI. It's super cool. Right, so my deployment completed here. So I've got this scale set. So if I look inside this resource group, let me just close this guy here. And I was here. So if I look inside this guy, I should have one here, which will be a virtual machine scale set. I didn't type website nicely, but it doesn't matter. So this is the virtual machine scale set. So you can actually specify how many instances are running. So in this case here, I've got 2 virtual machines running, which will be load balanced for the website, right? So rather than having one VM, it's actually got 2 VMs built off that golden image. So here you can see instances. You can see how many instances are in this scale set. And the scaling part of it is super easy, right? So there's a few different ways to scale. So you can manually scale. There's custom auto scale, so you can scale up based on schedule, metrics, etc. You can actually have scaling policies, which you define outside here. But the easiest way is like if you wanted to just manually scale up the machines because you knew Black Friday was coming and you wanted to scale it down manually, you can actually just drag this guy over here. I can say 79 instances and hit save. And it will spit up another 77 instances based on that image. I won't click it because this is my account here and it will charge me, so I'll just discard that change, but it's very, very cool. So that's basically a scale set. So scale set's kind of a VM plus. So a VM that you can, or a set of VMs that you can automatically scale. And I thought that rather than demoing creating a VM, which is super, you can just create a VM. It's super, super easy. You get a public IP and you can connect to it, whichever type of VM you like. I wanted to show you this feature of the scale set because I think it's pretty interesting and it's a unique Azure offering. Cool. Okay, so next demo piece. I wanted to show you guys what the web app looks like. So remember I was talking about there's a managed service where you can deploy your application into a web app where you don't have to manage the virtual machines themselves. I'll show you a bit about what that is. So let's say, Tailwind traders, they want to move a little bit more to a managed service model, which I agree with. They can use the app service as well, right? So let's say, Tailwind traders were they moved to VMs, they moved to a scale set, and then they go, actually, we don't want to manage those things anymore. So let's have a look at a hosted kind of app service. Right, so I'll show you what that is. So now I'm back on my portal again. If we go to app service, okay, so this is an app service, one that I created before. So the app service is literally your application running in the cloud. You can monitor, but you don't need to log into you can't log into the actual virtual machines, and you wouldn't need to. You can see this is the application. One of the interesting pieces to note would be configuration. So let's say you have some configuration, maybe some SQL connection or API URL or something that this application needs. Maybe this example here is the Tailwind Traders website. So the website would connect to an API, which is somewhere else. In this case, I'm using the public Microsoft sample one, but it could very well be a backend, connected into a backend service that you're running inside your cloud. Right? So this application, the connection stuff is one of the interesting parts. It's got all authentication, authorization pieces, deployment credentials. One of the you can also scale up and scale out this guy. So scaling up means if you want to increase the size of the machines that this app service is using, rather than using dev test machines, you can move to more specific machines. And scaling out is you can, like I showed you before with the scale sense, you can scale it out to have more capacity that direction. One of the cool things I want to show you, right, is called deployment slots. Right? So if you're into application deployment or you're familiar with working with applications, you know that deployment's probably a hassle, right? And you've probably heard about blue-green deployments or even A/B testing, right? Where you might want to deploy some configuration running in the cloud. Let's say you've got 10 virtual machines running, right? You want to have one running with one configuration and 9 running with another configuration. And then to test it, maybe test a new deployment, test a new feature, and then once you're happy with it, roll it out to the rest of the instances, yeah? So here you can do that with the concept of deployment slots. So if you see here, I've got or even A/B testing, right? So A/B testing is maybe you might want to, you have 2 different versions of your application, one which is a new branding. So the content team are giving you some new branding and you wanted to test out the impact of that new branding, right? So what you can do is actually you can create another deployment slot, which just means this application running with a specific configuration, and you can direct your traffic to each configuration depending on what you need, right? So let's say here in this example, I've got 90% of my traffic going to the production release, and I've got 10% of my traffic going to the A/B testing release, right? So then I can get some feedback based on that, and I can progress my features. So I think this is super, super cool. And it's really easy to change, right? So let's say I go, okay, actually, now I'm happy with that version. I want to make 90%. You can save, and it will go off, and it will change the traffic to be over there. So you can use this for blue-green deployments. So let's say you go, okay, put 10% now, no one's screaming, it's all okay, roll it up to 100%, and then do it again for the next release. Or if you want to do something like A/B testing, super, super cool. So that's probably my favorite feature of the app service. And if you're trying to do this without a managed service, it's going to be a hassle. Right? You have to manage all of that yourself. So that's really, really cool. Right. Okay. So that was the second portion. So I talked about some tools for building your application, some strategies for deploying your applications in Azure. Now I'm going to talk a little bit about basic security. So this is a pretty common scenario that happens. So let's say, okay, you've got a brand new business. You're selling. My girlfriend just started a new business. She's making curry puffs now, and I was making the website for her. Right. So I made the website. It's just me working there. I have the connection string details to my database. It's just with me, right? It's on my laptop. It's fine. It's kind of okay. Then let's say her curry puff business is kind of taking off, right? So there's a lot of people buying curry puffs in Singapore. It's super popular. So I hire 3 more developers, right? 3 more engineers. And then it's still okay. There's only 4 in the team. I think we trust each other. So what I do is I just give them the connection string to the database with the username and password on a post-it note. Right? Cool. Then for some reason, curry puffs is blown up. People are going crazy for curry puffs, and I hire another 9 engineers. So I've got a fair number of engineers now, it's okay. We're using Slack. We're a bit more evolved. So what I do is these guys just chat the password to them over Slack. Right? Then for some reason, there's her brand of curry puffs just goes gangbusters, right? And she's exporting curry puffs all over the world now. And I hire another 30 engineers, right, all to service this online curry puff ordering system, which is blown up, right? And I've got 50 engineers, and I also send them all the passwords over Slack. And then one of the guys, one day, it's not that engineers can't be trusted, so they're cool. I just send them all the passwords. But one guy, he loves to get coffee. He's always at Starbucks, and he's working at Starbucks, and he leaves his laptop open, and then someone's got the password, right? So then I've got a security breach. So there's a bit of a long-winded story, right? But what I was getting at is that there should be a proper place to store your secrets. You know, like as your application is growing, it's just a couple of people. Maybe keeping the secret on your machine is fine. But database connection strings, usernames and passwords, as your company grows or your development team grows, you have to look at somewhere a bit more secure than, you know, just in a Slack chat or just on a Post-it note to keep your passwords, right? So with you know, the growth of that curry puff business, it was going very well, but you know, there's some security concerns which need to be addressed. Right, so Azure Key Vault, right? So Key Vault is an offering that keeps you in control. So basically, it's a cloud service for safeguarding your encryption keys and application secrets in cloud applications. So Key Vault supports a clear separation of duties, right? So what that means is your application developers over here, they manage the apps and they don't manage the secrets, right? And you've got an operator who takes care of the secrets. So all the connection strings, they sit with that one person, they make sure that it's secured in the Key Vault, and they grant access to people or applications to be able to get the secrets from the Key Vault rather than handing out the passwords, right? So that's what you want. It's better. Also, if you're getting audited, there's also auditor permissions, so you can have a look and audit what's happening in the Key Vault based on permissions, right? So another person, perhaps an auditor, can complete log activities for the Key Vault. They can look at the logs, they can see what's in there, the operator manages the keys, and the software engineers don't all need the passwords anymore because I've been in that situation many times before where people are handing out the passwords and like, what's the password for the office Wi-Fi? And like, nobody knows, it's on a Post-it note somewhere. All that stuff should be in a vault. Right, so also with the Azure Vault, the logs themselves can be piped into Azure Log Analytics. So you can have a dashboard for all the activities that are happening against that vault. You can also do queries to see what applications are using what keys, set some alerts for when, you know, a key's being, some sort of compromise has happened, etc., etc. So Key Vault is an Azure offering. It's one of the products. It's super easy to create. I think I'll show you guys that, which saves you from just distributing passwords everywhere and gives you a place to store it. Right, so yeah, it does a lot of things for you. It's all secure. It's all in one place, so all your passwords are in one place, not sort of scattered all over the place. You can enable and disable keys easily. So let's say for some reason one of the keys you found was compromised, right? So rather than going like, oh no, okay, all over the code base, there's all these passwords and I got to chat all the development team, here's the new password and whatever, you can just update it in the Key Vault and then it's done, right? You don't even need to let people know, right? You can seamlessly move between your dev environments, QA environments using the Key Vault. And you can update credentials in one place. You version it, so you can version your keys. So, let's say you want to rotate your keys. So one of the good security practices, or if you need to comply with some security compliance, you might need to rotate your keys every month or 2 months, right? Now, if you don't have a Vault solution, you're rotating your keys, then you need to manage that manually, right? If you have a Vault solution, you can rotate your keys. It's easy, and it's easy to integrate with, which I think a lot of the historical, key management systems are difficult to maintain because they've been run by some administrators, but Vault's actually pretty easy to work with. It's also got a lot of compliance certifications, so certifications for a lot of different countries there. It operates like a black box and it secures the keys in a cryptographic sequence. So yeah, the physical security in Azure is actually, it's housed in HSMs, in Azure data centers. So special hardware security devices, that's where the vault stuff is if you're looking at the underlying storage of where the keys are. So that's managed by Azure. And yeah, Key Vault complies with a whole bunch of industry standards and certifications. You can see that there. You can read into those. And also, where applicable, you can actually look at the audit reports in the Azure Trust Center. So if you go to Azure Trust Center, you can look at the reports there. Right. Okay. So I'll actually show you how easy it is to secure a key using the Key Vault. Okay. So let's go back to this portal here. Right. So creating a Key Vault first. So I'll show you guys how easy it is. I've already created one, but I'll show you what it looks like. So if I went here, I could just go, not create a resource group, I can go create a resource, which is a resource that I'm using as well. I can say Key Vault. Boom. You choose create Key Vault, create, and you've got one. I've already created one here, so let's have a look. So I've got one here. I created this Tailwind Key Vault. So this is the Key Vault. You can hide keys, secret certificates. What I want to hide in here is a secret. Okay, so I've already got one here, but I think I can create a new one. So you can actually go generate. You can pop a new secret in there if you want. Let's grab something from my notes. Let's say it's a database connection string. So I can call this secure connection string. And the secret is actually this, right? So this is that connection string that people might have been using in the application, database connection string, right? So let's not worry about that. I'll just create it. So I've got this connection string here. Now that's securely stored in the vault. Remember how a moment ago I was showing you guys inside here, inside that app service, there was a connection string there. This app service. You remember how I was showing you in this configuration here, there's a connection string. So this is SQL connection string. So if the connection string is here with this app service, that means that it must have been in the code somewhere. So it must have been deployed with the application. So probably in the code base, it's got that connection string in some config file, or even if it's not in a config file in the code base, it has to at least be on the build server or the deployment machine, which gets it into this application here, right? So this string must be somewhere in order for it to be deployed as part of this application. And that's what we don't want, right? So what we want is we want this connection string to refer to or to reference what's something that's in the vault. So I'll just do that now. So if we go here, what you can do is I'll take this connection string. Let's not worry about this. So this is it. So you take a reference to the connection string. So I'm not actually taking the connection string itself. The secret is hidden away in the vault. But what I'm doing is I'm taking a reference, which is the reference to a URL which contains that secret. So then back in the code base, what you can do here is, so let's say you, instead of deploying with the connection string in it, you deploy with a reference to that connection string. And there's a special syntax used here. This. So you actually just go like this, Microsoft Key Vault, secret equals this. And so I'm saying that the value of this application setting is referring to this value in the Microsoft Key Vault. Does that make sense? So, okay, I'll just edit that, save that. Okay, let's check it all works. Okay, so this will update it actually, whenever you update the settings in the application configuration, it will update the settings and it will restart the application actually. But you see the magic here? You see how over here now it says, you can see it says Key Vault reference. So that's saying that, okay, over here, this connection string is now referring to something that's in the Key Vault, rather than having the connection string manually here. So it's secure from a deployment perspective. So on your build server, you just need to hold this reference, or on the develop machine, the code base, etc., you just need to hold this reference. Right? So that's actually how to use the vault. It's a lot easier than I thought. So just wanted to show you guys. Okay, so back on the presentation. So, all right, so don't you need credentials to access the vault, right? Isn't it sort of like a chicken and egg kind of thing? Like, see that URL, don't you need access to be able to get the key from that URL? How does that work? So, yeah, you're right. You do need access does need to be granted in order to get that key from the key vault. So within Azure, they provide something called Managed Service Identity. So what happens is your app service runs with a particular service identity, right? So the app service starts up, it runs as a service identity, say, Andrew's Tailwind app service, and then that app service gets granted permissions, or that app service gets registered with Active Directory, right? So, and then Active Directory grants permissions to that service to the vault. So without any sort of user intervention, right? So the app service starts up, service user, Active Directory grants access to the service user to be able to query the vault for that specific key. So that's kind of how it works. It's called MSI, Managed Service Directory. That's it. So yeah, you don't need to grant individual or user-based access. It's access. That application has access registered in Active Directory. And if there's a compromise, then it will change. So, and also, let's say if the app service restarts, what it will do is it's not stored within the app service. So the app service, when it restarts, it will requery again and will get new credentials. So that's kind of how it works behind the scenes. There's lots of documentation on that. So there's, this, you can follow this URL here, aka.ms /docAAD, Active Directory. So there's a lot to it. I mean, Active Directory is quite a complicated topic. So to learn more about permissions, roles, governments, everything related, have a look at this URL, and it gives all the documentation you need related to that. Okay, so what if it's not all in the cloud, right? So let's say you're moving to cloud, but some of your stuff you've left on-prem. Does everything need to be in Azure to work together? No, it doesn't. So you can have a hybrid. When you're moving to cloud, you can have a hybrid setup, right? So you have some of your stuff running on-prem, some of your stuff running in the cloud, and the stuff that's in Azure can interact with what's on-prem or directly outside, right? So if you think about a web application or a mobile application, there's the APIs hosted in the cloud somewhere, which is the same for every other app. You can have your APIs hosted in Azure, and then on your mobile application, it just queries out those APIs in the cloud. So that's pretty straightforward. Same with your data center. So let's say you have some SQL database living in your data center on-prem, which your Azure services need to connect to. So there's a few different options there on how you can create VNets or different networking setups to connect your Azure cloud services to your on-prem securely. So there's a few different options there, but definitely moving to cloud, you don't need to move everything at once. It's more of a stage-by-stage approach, right? So you move some part, keep some stuff on-prem, and then sort of migrate as you go, and saving the cost as you go, right? Okay, thank you very much for listening to the details of this particular topic. Next topic, we'll be talking about data, where to store your data in Azure, and options for where to host your data in Azure. Thank you very much, and enjoy the next video. Hi, I'm Andrew Whiteside. Welcome to the second talk in the series here, talking about options for data in the cloud. So just to wrap up on the previous session, we talked a little bit about options for building and deploying applications on Azure. In this session, we're going to focus more around data. So like where you store your data, what options Azure has for storing your data, and what kind of strategy you can put in place when it comes to fulfilling your data needs on the cloud. Okay, cool. So, last session I was talking a little bit about Tailwind traders. So they're the case study that we'll be investigating in this second session. So first of all, when it comes to looking at data, you need to have a strategy in place, right? So you need to be thinking about, what do you want to do with your data? What is the security you need for your data? What's the approach you should take when it comes to sort of designing your architecture data needs? So first of all, we're going to talk about what's important to Tailwind traders as a business. So for different applications or different companies, there's different needs. So, and based on the different needs, there's some considerations that you should take into consideration when deploying your data structures. So we're going to talk about what's important to them, choosing a data storage approach. So we're going to choose what approach based on what they need. We're going to talk a bit about the benefits of storing your files in Azure Blob storage. And we're going to talk about SQL Server in the cloud, how and what that is. And then we're going to talk a little bit about migrating. Let's say, these Tailwind traders guys have a MongoDB database running on-prem. We're going to talk about how you could potentially migrate that MongoDB application to Azure using Cosmos DB, which is probably the exciting part. Okay, so, all right, first of all, what's important to Tailwind traders? Okay, so Tailwind traders, they're a growing business. They are an e-commerce business. They provide power drills and whatnot. You can buy them online. They ship them out. So we want to have a look at the business. Like, what are they trying to do? So from Tailwind traders, what are they looking to do? They're looking to spin up features quickly. So that's important to them. So they're a very cutting edge kind of business. So what they want to do is they want to get some feedback from customers fast. And then let's say there's a new feature or a new application new part of the application they want to build. They want to be able to get that deployed out fast. They want to be able to limit the impact those features have on the existing production environment. So obviously production is important. They don't want, like, when they push out a new feature, that it breaks something in production. So that's something that's very important. They're important to probably most businesses as well. They want to put as much as possible in control of the hands of the engineers. So they don't want to have specific infra guys digging around with the storage because, if you're familiar with sort of having different teams in different silos, like often, software engineers, when they want to get the features out, perhaps they're blocked by a separate infrastructure team where, they need to provision infrastructure separately. It needs to get signed off, deployed, approved, and that's sort of that's what they want to avoid, right? They want to be able to go, okay, developers got that feature, they want to push it out quickly. They don't want it to go through this sort of red tape process, where, the engineers are kind of sitting on their hands for like a week, waiting for the infrastructure to be provisioned, right? Which I've had in the past. I've had experiences where I've been, running software for a particular company and, it took like a week before we could even get any kind of storage past or any sort of new storage or any sort of infrastructure provisioning past the guards of the infrastructure, So that's kind of frustrating. We want to sort of make that easier. They want to dynamically scale the storage without significant operational overhead. So if they get to a stage where they want the storage to scale, they want to be able to do it fast, easily, and they want to be using the right tools for the job, right? So often when it comes to software tools, people just pick, if there's a lot of tools, people will just pick anything or maybe what's on trend or something they heard about in a conference. So it's not always best to choose like the fanciest tool. It's more appropriate to choose the right tool for the job. So that's important to Tailwind traders, and they want to do things right, So, okay, so the importance of having a strategy, right? So same with anything. If you don't have a strategy, you don't know where you are and you don't know where you're going, right? So if you have a product, you're building out a new e-commerce application, you should have a strategy for what features you want to be putting in place. If it's when it comes to building a software application, the architecture, you should have a strategy for, okay, how are we going to modernize that architecture? Have at least a strategy in place. So the same goes for storage, If you don't have a plan, how can you ever get to a goal, right? So having a storage strategy is important. So what they want to do is, if it's having a strategy, it facilitates upgrading of legacy operational processes. So if you have a strategy, okay, when we want to upgrade, we need to do this. It allows for more velocity when creating more products and features. So you know, okay, when a new feature comes out, you need to do this, right? So having a defined strategy is a huge enabler for velocity. So it allows people to build faster and release better projects, really. It also allows people to break down projects into more manageable services and features, right? Also, having a strategy keeps the operations team from being surprised by new technologies that might have an impact on security or compliance, right? So one of the things about infrastructure teams, if you surprise them on Thursday and say, hey, we need this new technology, they'll be like, probably not going to approve it because they never heard of it before, right? But you have a strategy in place where you say, this is where we're going to be using this technology, everybody's clear on it, then you can move forward together as a group. Also, security is important, right? So as with everything, security is important in the cloud or on-prem or in my house. So we want to make sure that everything that's done is done to a certain security level. Okay, so looking at this next slide, you can see these are some of the options that you have for building cloud-native tools on Azure. If you look, even this one's out of date, but there's new features, new products coming out, every week, every month. And there's loads of them, and it's kind of confusing, right? You might look at it and go, okay, cool, I want to build my application on the cloud. I mean, what do I choose? Do I choose a little bit of everything? Wow. So and even based on these options, you can see that even within this larger sort of plethora, there is also a lot of storage options. So this slide actually shows the highlighted sort of just the storage options, but even there's quite a few, right? So I want to explain a little bit about what are all these pieces and when you should use them and which ones are kind of right depending on your needs. Right? So storage is just a part of the architecture, but also it's an important part of the architecture. All right, so which option do you pick? Right, so I'm sure most people might be familiar with SQL Server as an option for storing your data. I've also used SQL Server a lot in the past. Probably some legacy systems will be set up using SQL Server, and that is a perfectly valid option. So, but what I want to get across is that that's not the only option for storage. So just because it's always been done that way doesn't mean it has to be that way. But SQL Server is suitable for certain types of operations, and I want to sort of drill into a little bit about thinking about what data you want to store, where you should data, and choosing the right service for that approach, rather than going everything's data, it goes in a database. So how do you choose what's best for you? Right, so it depends. So I think I can't say it enough that there is no cookie cutter approach for your application in the cloud. All applications are different, and all products have unique offerings. That's what makes them unique. So you need to be building the right data strategy for your application. Just because you went to some conference or maybe you listened to some guy talking on some webinar who said this is the right storage option for them, that doesn't necessarily mean it's the right option for you. So have a think about the storage options and choose what's right for you. Right. Okay. So there's a strategy for it, right? So there's a good strategy about how to come up with what your plan is related to your data. So if you think about it this way, there's three types of data that you might want to store for your application, right? So these three types are structured data, unstructured data, and semi-structured data. Now, let me just break it down a little bit more detail about what these are. So structured data is your table data. So ordered data, your relational data, it has one specific schema. That schema doesn't change. It's a set of columns that are in each tables. And normally, when I say structured data, what I kind of mean is your relational SQL kind of data, right? So maybe it's orders tables, sales tables, customer tables, where the set of data is kind of structured and consistently the same. So that's kind of structured data. I think of structured data as relational data. Unstructured data is your blob data, right? So your image data, your binary data, some PDF file, all this sort of stuff. So that's where it's unstructured. It's just sort of blob data. So you wouldn't query it. It's just a chunk of data that's somewhere, an image or a video where you just pull it off the cloud and kind of do what you will with it, right? So it's not something that you need to query. That's what I call unstructured data. And semi-structured data is kind of halfway in between, you know what I mean? So semi-structured data might be a document, but the data always doesn't clearly fit into tables. So it might be something like key value pairs, some JSON documents, graph data, XML files. That's kind of unstructured data. Oh, sorry, semi-structured data. Right? So you think about structured data is your table data. Unstructured data is your kind of image data, just binary files that you don't query. And then semi-structured is sort of halfway in between. If you think about semi-structured as kind of like, if you think about structured as your SQL data, unstructured as your binary files, and semi-structured is kind of like your document stores, right? Your JSON, your NoSQL, if you like that term. So they're kind of three types of data. So you need to look at your application and go, hey, or Tailwind traders look at the application and go, what's the structured data I need to store? What's the unstructured data I need to store? What's the semi-structured data I need to store, if any? And where does that fit? Right. Also, when it comes to coming up with a strategy, you need to think about how much data do you have. So first of all, what's the volume of data? Is it gigs and gigs and gigs of video data? A strategy for storing gigs and gigs and gigs of video data versus a strategy for storing just a little bit of data might be different, right? You might choose a different product. So there might be data where it's a little bit of data, but it needs to be read very often. You might choose one solution. Or if it's a very large data that's kind of archived away and it gets pulled out very minimally, then you choose a different option. So that's what I mean when I say velocity here. So velocity is like how often you're going to be fetching that data or how often you're going to be reading into that data. So think about volume, velocity, and variety. Right? So variety as in what is it a variety of data, right? So is it always going to be the same format? Or is it always going to be something different, right? So is it maybe if I want to store in one storage solution, I want to store my images plus my PDFs plus my files, I might choose something else compared to whether it's always with one type. So these are some high-level concepts, but definitely good to reflect on these when you're building your application or when you're architecting your data needs. So look at what type of data you're storing, and how much data you have, have a sit down, write it down, use spreadsheets, documents, whatever, have a meeting, present. Make sure that you at least think about it before employing a data strategy. So think before you do. I mean, often I've been involved in software for a long time, and sometimes I just choose, in the past, we would just choose a product because it's cool, or choose because it's the most relevant tech right now. But it might not always suit your needs, right? So at least think about what you're planning to do before implementing a plan. Right, so Tailwind traders. Let's go back to the Tailwind traders, guys. So this is the data that they have. So they have a product catalog, which, if you think about product catalog, it fits into the structured data category. A list of products, fixed columns, price, description, etc. Product photos. That's an example of unstructured data. So they've got, for each product, it's a power drill, there's an image that comes with it. Your product photos is definitely binary data, so that's unstructured. And then the sales data is kind of semi-structured, right? So the sales data might be different columns depending on where the sale was made, right? So if the sale was made in Australia, it might be a certain set of columns, or if the sale was made in Singapore, it might be a certain set of columns because of different regulations and taxes and whatever that, fit depending on where they are. So Tailwind traders have got a nice mix of the three different data types, and we'll talk about sort of where's a good place to store them. Right, so storing files in Azure Blob Storage. Right, so Azure Blob Storage. Azure Blob Storage is the Azure offering for your unstructured data. So it's basically, I think I touched on it in the last video, it's just a file, a folder in the cloud where you can put your files. So you don't really need to put your images or your semi-structured data into a SQL database or whatever. You probably just want it living on a file store. So Azure Blob Storage is the perfect place for that. It's just you create a storage account in Azure, and you can actually, there's different ways to get your files in there. And also, when you have that storage account in Azure, each file can have its own unique URL where you can visit that file. So it's perfect for your images that are being used on your website. So each image is kind of in the cloud. You can click on it and view that image. And then from your application, you can actually reference that URL, which is in Azure Blob Storage. So Blob Storage is the perfect place for that. Yeah. And Blob Storage is kind of the core of all of the Azure storage, which I'll talk about in a bit. Right, so what else do Azure offer? So Azure offer a bunch of different storage services, falling into two categories. Some are under the infrastructure as a service category, and some under the platform as a service category. So in infrastructure as a service category, they have, first of all, disks, right? So let's say if you have a VM, you spin up a VM running in the cloud, you probably need some sort of disk attached, right? Like an actual kind of physical disk. So Azure provide physical disks, which you spin up, and then you can attach them to virtual machines. So let's say I have a virtual machine. For some reason, I need to have 8 different drives attached. What I can do is I can spin up 8 different Azure disks and then attach them to this VM. So also, one of the cool things with the disks in cloud is that you can actually detach from one VM or detach from one machine and attach to another machine. So that's cool. Also, there's you can create backups, snapshots, so like nightly backups of the disk itself, so that you can restore it later, or you also have a backup. Files. So Azure Files is a fully managed file service. So where you can upload specific files, it's a replacement for your on-prem file server. So you have a file server, you can access it using your SMB from Macs. So it's just like having a file storage in the cloud. So rather than SMB connecting to the local store in your on your on-premise or data center, you connect directly to Azure Files. So Azure Files is that option, and kind of replaces that file storage you might have on site. There's also blob storage. So blob storage is the one that I talk about. That one is, again, it's a folder in the cloud, but it's a bit more elegant than just allowing you to connect to it using SMB or as a file share. You can actually have a URL to the images or to the items in that blob storage. So that's kind of, it's a bit more elegant because it can be used for your software applications as well. There's tables. Table storage is, like I said, your SQL database. So within the cloud, Azure provides Azure Database Service. There's a few different flavors of that. There's a SQL Server, Postgres. I think there's a slide on that. I'll go through those. And another one of the storage options is queues. So if you've got a distributed application, you might want to store some data in a queue so that it gets picked up and processed later. So, I mean, video encoding is a perfect example. Let's say you have some, you're uploading some files. It's photos from your Instagram or something, and it goes in the queue, and then perhaps there's a service pulling those files off the queue and processing them into different formats for iOS and for Android. So I mean, yeah, there's a lot of those, and we can definitely go on about that a lot. But I think that the long story short is that everything depends on storage. So it's got to be, if it's in storage in disk, storage in memory, if it's part of a database, the data must be persistent at the end of the day. And even though storage might not be so sexy, there's no bad day like a bad storage day. Yeah. So if you've ever lost data, you'll quickly realize that storage is important. So yeah. Right. Okay. So Azure. To highlight a couple points. The Azure is definitely global. There's 60 regions, more than 60 regions around the world and growing. It's heavily invested in security, so the security is definitely a big concern. There's all the, I could probably do a whole talk on security, which I think number 5 will drill more into security, but just know that Azure is heavily invested in security. And there's 93 compliance offerings from certifications that they abide by, like GDPR is one, PAPD, personal PDPA or something is another one, but there's all these certifications that Azure abides by. Azure data centers are hosted in 54 regions worldwide, and that's important, especially because a lot of applications I've worked on, they have strict data requirements, right? So they often require that like the personal data or data related to the application must reside in the country where the data was gathered, right? So having 54 regional data centers on Azure makes it a very good choice if your data needs to be stored in a specific region. So saying a lot of Singapore companies, in Singapore now, so a lot of Singapore companies, especially larger organizations, they must ensure that the personal data is stored in Singapore. You can't store it in a data center somewhere else. And having an Azure region here in Singapore means that it's a kind of easy choice, right? So what's blob storage, right? So yeah, blob storage is Azure's storage platform. You can store and serve. Serve is the important part. So you can store, but you can also serve via a URL. Unstructured data. It's mainly, I'd use it for app and web scale data, backups and archives, or for collecting big data from IoT, solutions, right? So if you've got a lot of data, blob storage is probably where you want to throw it, So yeah, it stores it in blocks actually. So Azure, blob storage is kind of at the core of everything. So all of the other services that are provided by Azure, most of this underlying storage is actually blob storage. So, for CDNs, for analytics, for, if you look at this slide, a whole bunch of different things. The blob service is sort of at the middle of it all. So blob storage is used to enable a whole bunch of different scenarios. It's ideal for cloud workloads. So there's limitless scale, so you can just keep uploading files to blob storage. I don't know if there is any limit out there. I think I just keep uploading stuff. People just keep uploading stuff. There's hundreds of companies using Azure, and they're all using blob storage. So the scale is infinite. It's globally accessible because of the many regions that the blob storage is there. So you can actually set up your blob storage to replicate to many different regions. It's also cost efficient, so it's the cheapest option, right? So you don't need to host it in a SQL Server database or anything else like that. The price is very, very cheap. So if you look at the Azure cost calculator, you can see that blob storage is the cheapest option for storing your data. Blob storage. Okay, so I'll just demo quickly what blob storage is. So just to show you what it looks like. So I created one storage account, which contains my blob storage. There's something called geo-replication here. So you can actually set here that there's a few different options for replication. So one option is local redundant storage. So locally redundant means that within the same Azure data center, a copy of it is kept. So that means that it's recoverable in case of an emergency. Geo-replicated data means that, let's say my data is being stored here in the East US, it's actually being replicated over to the West US as well. So if for some reason something happens on the East of the US and that whole data center becomes inaccessible, my data is still safely replicated into the West US. So you can have geo-replicated data out of the box, right? And to enable it, you just go to configuration here. And so, yeah, you can set it to be locally redundant, geo-redundant, or read access geo-redundant. So it's just a matter of clicking there, and then you save it, and it's done. So that's, but I think I did that already. So also, yes, that's right. So you can specify, obviously, where you want to duplicate your data as well. Right, it's the same with all the other Azure services. It comes with your access control. There's also this piece called Storage Explorer, where you can actually view what's stored in your blob storage in the browser. So for this particular one, it's just got some log files in there. I didn't put anything in there actually. So it's just a sample of what it might look like. And if you want to access your data without using the browser, another way is to use me just switch my screen to here. There's a tool called Azure Storage Explorer. So this is downloadable for Mac and for Windows. And over here, you can link it up to your account. In my case, it's linked up to my subscription. And it shows, all the different storage accounts that I have here. Where, I'm not sure where I put one in, but it's kind of there. But it's quite cool. So let's go back. So that's basically what the storage is. You can also use it for, I mentioned quickly about having a static website. So if you go here, you can have, static website, right? So you can actually have, if you wanted to host your static content in this storage account, you could just deploy your files in there and you enable this, and it will be able to host, a simple website, perhaps, your company front page. Right, okay, so, right, and now we'll talk a little bit about relational databases in Azure. So, blob storage is the correct place to be putting your unstructured data, but relational databases is the correct place to be putting your structured data. So, if you've got structured data, there's Azure SQL database as a service. The options include you've got SQL databases, PostgreSQL, MySQL, and MariaDB. So there are different options that you can choose for your Azure database service. And it's also much like I explained the app servers, it's another hosted service in the cloud. Now, I'm a big fan of having managed services, right? So if there's a managed service where you can host your SQL data and all you need to do is query the data and push the data in, I'd strongly recommend going with the managed service. Traditionally, if you have a VM, maybe you have a VM or a physical machine, you might install SQL Server on there, and then you need to manage the memory, the usage. You need to tune the queries, the backup, the recovery. You need to handle all that yourself, right? And I've done that a lot on older projects in the past, And once I found that there's cloud providers that provide managed services for it, I started to switch, right? So any applications that I have, I can move it to the managed service, because 99% of the features that you will use in a SQL database are available in this managed service. So the only time you would need to sort of have your own handcrafted SQL server running on a server is when you are using a feature that doesn't exist there. And I challenge you to tell me where you're using a feature that's not provided by Azure database service. So using a managed service saves you money because you don't have to have somebody taking care of it, right? And that normally, if you have someone taking care of this kind of managed service, it needs to be a DBA, highly trained, hard to find, expensive, and it's a waste, right? You can use that money to invest more in the features, right? You don't want to be spending your money or your application time on developing the ceremony, right? You want to be working on adding new features that bring value, not maintaining the behind-the-scenes stuff that can be managed for you. So I'm just ranting about that. Right, so there's a few different flavors of Azure SQL database that you can go for. One is having a single instance. You have a single instance of your database where it's you just have a single database for simpler loads. You can use an elastic option where if you want to scale up and down as needed. So let's say you know that the load is going to be larger here and smaller there. You might go for an elastic option, and then the premium enterprise version is called a managed instance. So the managed instance contains all of the features that you might need, your replication, it's fully managed by Azure. So they're the three different flavors: single database, elastic pool database, or managed instance. They come at different price points, but also again for different purposes. Yeah. So single you might need elastic, or maybe you might need the managed instance. Azure database compatibility. So so working with the Azure SQL database, if you've been working with SQL Server before, it's familiar, right? So you know the queries work, You know everything's the same. You can port your application from a unique on-prem SQL Server into a SQL Server in the cloud just by changing the connection string. So if you take your data, port it in there, change the connection string, boom, boom, you're done, right? So that's familiarity, right? So that's why I would say, port into cloud first before sort of investing in changing your application. Also, there's tools, so familiar tools like SQL Management Studio. There's also APIs for accessing the database. There's Azure Management Portal. It also has HTML support. So in the Azure portal, you can see there's a Storage Explorer. It'll run queries, SQL queries. You can actually do that right directly in the browser. Or if you want the native experience, you can go with Management Studio. It also supports seamless development, kind of online, offline, against on-prem, cloud-designated apps with Visual Studio, right? So flexibility, if you work with Visual Studio and hosted database SQL Server, it's pretty flexible. Right, okay, so migrating from, this is the interesting one, right? So SQL Server is the option. I mean, I can show it to you if you like. It's actually I don't have one running, but it's pretty straightforward. It's just in the Azure portal, and to create one, it's just a matter of like create a new resource. You choose SQL Server or maybe Postgres if you want to save on cost. So Postgres database, and then you just spin it up, and then it's there. You've got a connection string you can work with. So that's very, very easy. I want to talk a little bit more about something more interesting, a more unique offering rather than SQL Server. I want to talk a little bit about Cosmos DB. So Cosmos DB is Azure's sort of offering for NoSQL databases, but it's kind of more than that, right? It's not just NoSQL. So it's a premium NoSQL solution, globally distributed by design. So what I mean by that is that you can actually replicate your data across any of those regions, and the Cosmos DB has been built for that from the ground up. Right? So you can create your data over in Singapore, be uploading data to Singapore, and then replicate it to 18 different regions if you wanted to, depending on where your clients are, and have data feeding into there, and it replicates back across. Right? So that's super, super cool. There's also like 5 different consistency levels for reading data, depending on how acceptable it is for your application to read consistent data, right? So think this way, right? So let's say I've got, I upload my data to Singapore, and I have a region in KL, and in Australia, and in Japan, or whatnot. So I can say that, okay, for my data, when I update, let's say I'm updating a name record. I'm updating my name from Andrew to Andrew X or whatever. So I can say that if I update the data here in Singapore, that it doesn't read the data, it won't read the data until it's replicated to all. Or it's acceptable to have a dirty read, and I'll read from whatever happens to be in that region at that time. So I upload here, Andrew X, and then slowly it's cascading out to all the other regions. But I can choose my consistency level and say, okay, for my application, the consistency is most important. I don't want people to read data until it's fully replicated. You can set that in Cosmos DB. Or the other option is it's kind of acceptable to read dirty data, depending on what it is. Like, let's say updating my name is probably not that big a deal. You could probably set it to go, okay, just read whatever they have at that time and go ahead and cascade in the background. So there's 5 different levels for that, and you can choose that depending on your application or depending on what data you're storing, right? So you can, let's say it's payment data or credit card balance data or whatever you probably don't want to read until it's cascaded everywhere. Perhaps if it's like name data, product detail, description data, you might want to read whatever's in there at the given time, right? You don't have to wait for it to. So that's pretty cool. And that feature I haven't seen anywhere else. So Cosmos DB provides that. Also, it comes with some compatibility APIs, which provide an abstraction layer on top of Cosmos, right? So if you see this slide deck here, it provides, so there's a NoSQL database at its core, right? That's what Cosmos DB is. But there's an API layer on top, which allows Cosmos to sort of emulate being other databases, right? So other database structures. So it emulates etcd. One of the interesting ones is, say, MongoDB, right? So you can choose to interact with Cosmos DB directly, or you can choose to interact with Cosmos DB through the MongoDB API. And if you're going through the MongoDB API, then migrating from an application that's already on Mongo to Cosmos is kind of just like a click of the fingers, right? So that's also super, super interesting. So Cosmos DB really is a premium offering. It's got a lot of cool features. It's not just your, your NoSQL database, but it's got these additional APIs as well, right? So supports like Spark, Cassandra, also a table format. So there's a SQL format API which you can use to interact with your Cosmos DB. Right. So then this particular example is showing the MongoDB wire protocol. So that's what it's called, the interaction with MongoDB. So if you have an existing application that's written in .NET or Node or Python or whatever, and it's interacting with an existing MongoDB, you could really literally just switch that from move the data into Cosmos, switch from using that MongoDB connection string to this one, and then the application should work. So yeah, it's really, really easy. So Cosmos, when I first heard about Cosmos, I was like, man, not another NoSQL database that I got to deal with. I got to learn how to interact with different APIs. The benefit of this one is that it's already got the APIs on top, so when you interact, it's super, super easy. So yeah, I think for me that was really cool to learn it. I thought that it was going to be another thing that I have to learn, another thing I have to interact with, but with these APIs, like Cosmos is actually super, super cool. Right, if you want to look at Cosmos in details, you can have a look at this Cosmos calculator. So it takes into account all the settings that affect the cost of using Cosmos DB. So if you have a look here, like remember I talked about that redundancy levels. So depending on the redundancy level, it might affect the cost, depending on the data, the volume, etc. You can have a look at this cost calculator to have a look at and see, what would be the cost of using something like Cosmos DB. I think they're probably cheaper than using SQL Server, I'll say. So here's the docs, all this stuff. Actually, I'll give you a quick demo on what Cosmos DB looks like before I move to this. I think I didn't have a slide for it. I'll go over there. Right, so here is a Cosmos DB that I created in Azure, right? So, and again, to create it, it's pretty straightforward. You just can say Azure Cosmos DB, off you go, and it will create, right? But we'll create one or you can do it, like I said, or you can do it via the CLI, or the Cloud Shell command that I showed before. So if you have a look here, I've got one that I created. I think I put it in this one, sorry. Right, so here's a Cosmos DB. Now, with Cosmos DB, there's this tool called Data Explorer, which I think is super cool. If you go to Data Explorer, it actually has, so I've got a sample database in there, right, with just a person's data, and it's actually using the SQL API. So remember how I mentioned there's a MongoDB API, and there's other APIs for interacting with the data? This one's actually, select star from, C, right, but that's just this data. So you can see that it uses a SQL API on top of the Cosmos DB to pull out my data. So that's really cool, and it comes with all the other database features you might expect, So actually, I'll show you one more thing. So if I go to one more screen, you can see here that you can actually get to the Cosmos DB stuff from inside here as well. So inside the Azure Storage Explorer, you can dig out the Cosmos DB stuff. One more thing that's pretty cool is I wanted to show you is the replicate data globally piece. So if you have a look here, so I've got my Cosmos DB here sitting in the East US, right? You can see a little tick. So in order to replicate the data to other regions or to set it up so that it replicates to other regions, let's say I want to replicate my data to Singapore. It's just a matter of ticking that. And I can set if I want to have multi-region rights. So let's say I want this one to be the source of truth, and I only want read-only data over here. I can set this to disable. But if I wanted to, I could also enable it to have multi-region rights. So that let's say I've got replicated to Japan and down here in Sydney, and I save that. And it will go ahead and it will update my Cosmos DB so that when I write, I can write to here, 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 and it will replicate to those regions automatically behind the scenes. So that's a really unique offering, right? Like I haven't seen any other NoSQL databases which allow that. And I think it's really, really cool. So that, and it's easy, right? Like it didn't, you don't really have to do much to it. And also, to be fair, you can also do that through an ARM template, which I mentioned before. So if you define in your ARM template, in the JSON structure, you said, okay, I want to replicate to this region, you can define it in your ARM template as well. So I do recommend that you don't do things like this through the UI. Everything should be built out using an ARM template. Okay, cool. So back on the slides here. So just a little bit more about docs. So there's a lot of docs related to Cosmos DB. There's a lot of samples related to Cosmos DB. They provide a bunch of sample ARM templates. So I think even the one that I've got here is just a sample ARM template. So you can go onto the website, grab a whole bunch of ARM template samples and play with it yourself. I think if you haven't already, just grab an ARM template, it'll deploy at the database. You can have a play with it and see that it's not that complicated a database to work with. Right? I thought it was going to be, but then after learning, I found out it wasn't. So, that's pretty cool. So, just to recap, I think I've got to the end of this talk. So, but just to recap, I think we talked a little bit about data options in the cloud. I think the points I want to make is like, first of all, make sure you have a strategy or think about what you're doing with your data. Look at, is it structured data, unstructured data, semi-structured? Then have a look at, volume, velocity, and variety. What kind of data? Create a strategy that you want to build, create a strategy for what you want to do with your data, and then find the right tools for where you want that data. And I think like blob storage I talked about, which is suitable for your unstructured data, SQL Server or Azure database service for your structured data, and Cosmos database for sort of what's in between, And yeah, so thanks very much for joining on this one. This was talk 2 in the series of 5. Join me in the next one, which will be on containers, so specifically on how to run your application in containers. Thanks. Hi, welcome to the 3rd video in this Azure Cloud Native Training Day series. I'm Andrew Whiteside. I'm going to be presenting this 3rd talk. The 3rd talk, we're going to be discussing more around modernizing your applications with containers. And this is the 3rd in the series. This is probably, for me, I think it's one of the more exciting ones, talking about how to get your application working in containers. It's definitely a hot topic right now. It's something that I'm sure you guys are interested in. And I'm going to give you a little bit of an overview of sort of how containers can help, and then sort of try and do a little bit of a deep dive into some of the details of containers and how they might work for you. Right, so the goals for this session, we're going to talk firstly about Docker, containers, registries, what those things are. Then we're going to talk about modernizing our app with containers. So we're going to take that Tailwind Traders example and see how we could modernize that application with the help of containers. Then we're going to review endpoints for migration. So looking at what would be the right things to migrate from the application to containers. Then I'm going to give a bit of a demo of like how easy it is to create your own container from some source code. Push it into Azure Registry, then from Azure Registry, create a new web application which is built from the image that we built. So a very quick demo on that when we get to that. Cool. Okay, so first of all, you have to think about your applications. Where are your apps? And no, the App Store is sort of not really where your apps are living. That's not really the answer to what I was looking for. I was looking to think about where are your apps hosted. Now, for some of you, your applications might be hosted in a data center. So in a data center, they come with lots of redundant power, security, air conditioning, secure facilities where your physical machines are hosted. They require a lot of uptake, looking after the machines that are in data centers. If something goes wrong, you need to send some guy down to the data center, or you need to get remote hands to take care of it. It requires a lot of work, But really, are you in the business of taking care of, the machines that are running in your data center? I like to think about it like driving a car, right? So, I drive my car to work every day, But by no means am I a mechanic. If something goes wrong, I don't need to take care of it, know how to fix it, tinker with the engine, that sort of stuff. So while you're in the business of building software applications, and I'm also in the business of driving my car to work, I don't need to nor want to be an expert in maintaining that vehicle, right? So same with the data center. If you have things hosted in a data center, you need to kind of be an expert of maintaining that vehicle of hosting your application. So some of you guys have it in data centers, but do you really need to? Is that where you want to sort of spend your effort? Some of you guys might be hosting stuff in virtual machines. While that's better than hosting in a data center, there's still overhead with the virtual machines, right? So you don't need to take care of the air conditioning, the networking, or the security sort of portion, physical security of the machines, but you still need to maintain the operating systems, right? So you need to patch the OSs, you need to spend time on managing backups, making sure that deployments work, all these sorts of things. So where else can you go from there? How can you make it easier? Okay, so, looking at this, thinking about, when everybody else is sort of out there kind of enjoying their lives, partying because the applications are running smooth, you need to spend time sort of making sure that OSs are working, patched, things aren't going wrong in the data center, really a lot of time on operations, and you want to kind of avoid that. So what you want to do is you want to feel like this when you're thinking about your infrastructure. You want to feel chill, relax, know that it's working because someone, a cloud service, is taking care of that for you. You want to feel more zen when it comes to your infrastructure rather than the stressed sort of crazy-haired guy that I've been before when I've been looking after the infrastructure. Okay, so let's get you on that path, right? So let's have a look at how we can get you, if your stuff is hosted in a data center or in virtual machines, how we can get it to a place where you can feel zen, right? You can feel like it's already looked after. I know that it works, it's resilient, and I don't have to babysit my infrastructure. Right, so drawbacks to hosted applications. So one of the major drawbacks is cost. Obviously, the cost with having a data center, it's pretty expensive, right? So you need to pay for the whole year. You need to pay for the security. The actual cost of running things in a data center costs more than sort of setting it up in a cloud environment. One of the biggest things for me is assume scale, right? So you shouldn't assume in life. But if you have a data center, you need to build your data center to cater for the load that maybe you're going to expect in the next year, right? So, or the next 2 years or whatnot. So let's say you've got an application, it's got, 1,000 users at the moment. You need to build into your machines in the data center or even into your virtual machines. You need to build in the enough capacity to cater for the next 6 months or the next year. So let's say you got 1,000 people now. You need to build into your data center the ability to cater for 100,000 users, right? At any time. But you might not get to 100,000 users. You're only kind of guessing. Or you might get to 200,000 users and then you're like, oh my God, my data center can't handle it. I need to reinvest another chunk of money into that data center. So you can't the cost is not directly related to your current usage. It's related to your assumed usage in the future. So that's sort of something with hosting in a data center that there's a problem. Also compliance and regulation, you need to kind of manage it yourself, right? So you need to make sure it's secure, you need to tick off all the boxes, you need to make sure that all the machines meet compliance, et cetera, et cetera. And that's kind of something that's really boring work. And if somebody can do it for you, then cool. Okay, so VMs are great. So VMs are the next sort of evolution. They're great. You don't have to spend that money on the data center stuff. Much, much better. However, like I said, you still have the OS to manage. There's still a long startup time. So let's say, okay, cool, your application is scaling. You go, oh my God, we need new machines. You need to add a new machine. You still have to wait for it to be provisioned and start, right? So that could be like 5 minutes, 10 minutes. Obviously much better than a data center. If you want to provision to a data center, that could be weeks, months. It's down to 5-10 minutes, but it's still 5-10 minutes, right? You want to be able to scale your application as and when needed, so that, perhaps peak time is in, UK working hours or something. There's more machines then, and then more processing power then, and you want it to scale down when it's sort of the quiet time. So if there's 5-10 minutes, you might have some problems with latency or whatnot. Also, there's more things to monitor. So, you have to monitor the OS, you have to monitor all the other bits and pieces that come with it. Right, so I'm going to talk about modernizing with containers. You've probably heard about containers. If you haven't, I'll be surprised. This slide says it's a new way. It's not particularly new. It's been around for a few years, but we're still on the right end of the curve, right? So it's not in the sort of early adopter phase where, potentially some people will adopt and then it disappears. Definitely it's on the higher end of that spectrum where it's being adopted by most people as a tried and tested technology. There are still a lot of companies looking to move into the container world, and I'm here to help, and I want to be able to show you guys so that I can show you guys so you can help to understand how you can get your application into containers and what that means. Right. So what is a container actually? So okay, if you peel away all the hype, right, all the buzzwords about that you heard from some other tech talks about containers and whatnot. All it is that a container sets a clear boundary for your applications, allowing you to know which assets belong to it and which applications own it. So basically, it's a standardized way of packaging your application, its dependencies, and the runtime environment into a portable container that can run anywhere with the same outcome. So it's packaging your application up into a little box container, which is portable and can run in different places. They allow for better resource utilization because they don't have the overhead of operating systems, and I'll show you a diagram about that will explain that clearly in a bit. And containers only need to be provided with runtime data like connection strings, etc., not a whole bunch of additional configuration. You put that into what's called a Docker file. Right. Okay, so why would you want to move into containers? So one of the problems is, if you're running an application on many different types of environments, there might be many different configurations. And, the classic example is the works on my machine that you'll hear from software engineers. So they'll have one setup on their machine with this dependency set up, etc. And they'll click, works on my machine. And then when it goes to production, it doesn't work because the configuration is slightly different. You ask the engineers, they go, it works on my machine, no bugs to fix, arguments ensue probably. So containers allow you to build a container which it'll run in the same way on production, on staging, on the developer's machine, etc. And every environment's sort of the same. So that's one of the major things about containers. Every dependency needed by the application is included in the container already as part of the sort of the base operating system, regardless of where the image is deployed. And it kind of equals productivity, right? So increased velocity, etc. Now, the whole DevOps thing is about decreasing your cycles for debugging and diagnosing and fixing issues, right? So developing containers helps to make that cycle faster. So if there's none of that works on my machine, if it's easy to deploy, if it's can move faster, then essentially you can focus more on developing new features at a greater velocity, right? So that's the whole point of moving to containers. That's the whole point of DevOps, so that people don't have to spend time on ceremonious stuff like making sure that the temperature in the data center is okay and this sort of junk. You want to focus your engineers and your operations folk to be spending their time working on features which bring benefit to users, right? And that'll make them happy, makes you happy, everybody happy, right? Okay, so containers run everywhere. So containers run on Linux, Windows, all the cloud providers, including Azure, they have container sort of runtime environments. Also, you can run containers on edge devices, drones, Raspberry Pis, IoT devices. I recently was working on a project where we deployed containers to edge locations for sort of a safety application. It was really, really cool, and yeah, you can run containers anywhere. So containers aren't just for cloud, they aren't just for servers, they aren't just for servers, they can run on edge devices as well. So it's kind of an architectural pattern that's applicable to a variety of different things. How do containers work? Okay, so this is the tough part. Okay, so as I mentioned before, like containers are basically highly configured processes. They leverage the kernel, so they use the kernel to isolate these processes so that one container does not consume the resources or does not overlap with other containers that are running in the same machine. You can see C groups are the ones that control the resources. Namespaces control what the processes can see, and the shared OS is the key differentiator when it comes to containers. There's a shared OS, and the containers are basically processes which have separate, they're separate processes which run independently. I'll talk a little bit, I'm just talking basically about containers here. I'm not going to talk about container orchestration. That's something that will come later in this series. So I'm talking about what is a container. Right, so I think this example gives it in the best detail. Like this is, I can remember this example from when I first learned about containers. Essentially, if you look at a virtual machine, here's an example of a virtual machine on the left. So you can see on a virtual machine, obviously there's the infrastructure, the hardware and stuff, that the virtual machine lives on. Then there's the host operating system, which runs on that infrastructure. Then normally there's a hypervisor, which allows you to run and configure the VMs, maybe VMsphere or vSphere or other hypervisors that you're used to. And then the virtual machines run on top of that. One of the interesting things to note is that you see in this diagram, like each virtual machine also has its own operating system. So that's the overhead, right? So you've got the base operating system, then the hypervisor, then each virtual machine has its own operating system as well. So when you boot up the virtual machines, they need to start up their own operating system and then run. So you kind of got this double up of operating systems where you probably don't need to, and that's the fundamental problem that containers address. So if you look at the diagram on the right, containers in a container environment, what you have is your infrastructure. Then you have your operating system, still the same. Then you have your container engine, which, there's different environments. It's Docker. So let's say today I'll be talking about Docker. So Docker is your container engine. And then on that container engine just runs the bins and the libraries you need for your application and the application, right? Rather than the OS as well. Now, that's really, really cool. So then when you think about containers starting up, they just start up the container. They don't need to start up the OS because they use they share the underlying operating systems, bits and pieces, right? So another way that I heard about it that I think is pretty cool, I think I'll explain to you guys. So if you're in Singapore or if you're familiar with Singapore, I think of like a virtual machine as kind of like a landed property where the plumbing, the electricity, the gas lines or whatever, there's all independent plumbing, gas lines, etc., going to the house. It needs to be built. Containers are kind of like your HDB apartments, right? So they have the shared, plumbing, shared water pipes, shared gas and electricity. So that's kind of the way that I think about it, right? I think about the landed property versus HDB kind of thing. So if you ever forget that, then just think about that. Okay, so Docker. I mentioned Docker before. Maybe you're not clear on what Docker is. So Docker is basically a daemon which is responsible for starting and stopping and sandboxing containers to run on a Linux host. That's it. So it's the most popular runtime engine. There are other Docker runtime engines like Cryo, Dockerd. They all satisfy the Docker interface. But Docker is essentially an interface. Docker is the most popular runtime engine. The concept of containerizing has kind of actually been around for a while. but it was a very manual process, often done just by a systems admin. What Docker actually have done is they made it elegant for engineers, software engineers, to be able to build containers. So it was possible before manually by some sysadmins, but it wasn't really used because developers didn't know about it or didn't have access to be able to do it. If you had to ask the infrastructure guys to provision me a new container, it's like, it's going to be a lot of hassle, right? But if you can provision and build your own stuff into containers, that's not very easy. So that's the beauty of what's happened with Docker. The Docker file kind of allows that. So containers originally weren't made for shipping new software. They was actually originally built just to separate different processes. But eventually with Docker and Docker files coming out and more people knowing about this concept, it's become sort of a cloud migration strategy, right? So, or a cloud architecture strategy, which makes sense. So that's kind of a little bit about the history of Docker, just to give you guys some relevant information to it. So, yeah, it wasn't originally designed to be an architectural pattern, which I guess most things are never designed. Never planned out from the beginning. But yeah, it's turned out that way, and it's turned out very very popular at the moment. Right, so a little bit about the guts of it. So this is the guts about the components that make up Docker. So if you look down here, I've got this container runtime section. In there, you can see run C. So run C is the magic component which allows containers to run as an isolated process on machines. Whereas container D is responsible for managing the containers themselves. If you have a look there, the container engine component, that provides that's the next kind of layer up. That provides the different capabilities to the container, like storage, your networking, etc. Then if you look at the top portion, you can see that there's that's kind of development tools, the integrated lifecycle management section there. That's development tools which allow people to develop applications in Docker, such as build tools, APIs, etc., which is used by developers to create and interact with Docker images. Docker containers, sorry. Right, okay, so what's a Docker file? So Docker file is just a text file which contains instructions on how to build a Docker image. You can see it looks kind of like a bash script. It's got, it's kind of readable. It's got lines, line by line, has different items. So each line is either making changes to the root file system or changes that are associated with the image. Each new line also results in a new layer being created for the image. So if you look at how images are built, they're built up on layers. So start with the OS layer or the base image layer, and then each line adds a new layer to the build. You can try that out in detail. I think that's a bit of an interesting concept to understand. But once you do some reading on that and try that out, I think that'll make more sense. But just know that that's there. You don't really need to know in full detail. Yeah, so that's it. So that's basically what a Docker file is. So, like I said, containers aren't new to Linux. What Docker's done is just to package the application in a simpler way, and Dockerfile makes that happen. So you make use of simple scripting to tell Docker what you need. So this is a very simple Docker file, which I think hopefully most people can understand. You can see the base image there. It says from Python, so it's using a Python base image. Then it's just setting a work directory, copying some files, installing a pip package, exposing port 80, and then setting an environment variable, and then just executing the Python command. So that's what a Docker file is made up of, a simple one, and what would happen when you do a Docker build. So what's a build? So a build is the action of building a container image based on the information and context provided by the Docker file, plus additional files. So build is important. So it's giving an immutable perspective for users. So when you build, it's just like building an application on, say, a build server. Let's say you've got a .NET application and you perform a build. It will build the source code and compile it into binaries, right? So Docker build is the same concept. So you're just compiling all the, compiling the code, doing all the Docker file steps, and building it into an image. So that's what a Docker build is. I think build concept, I think most people should be pretty familiar with. So here's an example of what a Docker build looks like. So this is just running Docker build from my local machine. So here I'm just saying Docker build, and putting the image name and a tag name there. So I think we can have a look at it one more time. So Docker build, got an image name there, tag name, and then dot, which is the, saying build from this folder. So that's it. You'll execute all the Docker image steps, and boom, that's your build. So that's what a build is. What's a repo? So repo is short for repository. I think probably some Australians come up with that name because we shorten everything to something with an O. You've heard ambulance is ambo, or afternoon is arvo, avocados are avos, and repositories are repos. So a repo is just a repository for your Docker images. So much like you have source code, like GitHub is a repository for your source code. Maybe NPM is a repository for your node packages. NuGet, Bower, etc. So they're repositories of where you would host your builds. So a Docker repo is just a repository where you would host your built images. So once you perform a Docker build, you push it into this repo, and then when you deploy, you would pull from a repo to deploy. Yeah, so repository is that. A single repository can contain many platform variants, so they can contain Linux images, Windows images, etc. So that's what a repo is. Okay, so here's just a simple example of listing some Docker images from the command line. So if you connect to a repo, you can just list out, like say we go Docker images, that's it. So it's just listing out, this is actually not from local actually. So when you list out the Docker images in a repo, they'll just spit out, it will show you, a list of all the images in that repo. Same as if you list it out from other types of repos. So what's a Docker manifest? So a manifest is a list of image layers created by specifying one or more, ideally one or more image names. That's super wordy. But what a Docker manifest is just the definition of what that container will be, or the definition of that image. So when you create and build, it builds it into a manifest file, which is a YAML file, and it's just the definition of what will run when that container will run. So if you think about a manifest, it's just like the build image definition is kind of the manifest, right? So if you have a look at what a manifest looks like, manifest looks like this. So you can see that in each layer, it might be a little bit complicated. You don't need to know the details actually of every piece that's in a manifest. I think it's good to just know that there is a manifest there, and know that if you want to interrogate, okay, what is this image? What's built into this image? You can look at the manifest file and see, what it looks like, right? You want to see the configuration or whatnot. So here you can see that each layer has a hash. Each different layer has a hash, and the OS, and the details that make up the container there. Right. So what's Azure Container Registry? So Azure Container Registry is Azure's flavor of container repo. It's a public resource for working with Docker and components in Azure. So the reason you want to go for Azure Container Registry is because you probably want to keep your registry close to your deployments. So if you're deploying to cloud, you want your registry to be near there because when you deploy, it will pull from that registry, right? So if you're deploying to Azure in Singapore, you might want your Azure Container Registry in Azure Singapore because you don't want it to be pulling the images from somewhere else, right? So you probably wouldn't have a repo hosted in, Greenland. You probably wouldn't host a repo in Greenland if you're deploying your application somewhere else. So having your Docker repo close to your code makes sense. Azure Container Registry I think is really cool. So it's actually Container Registry ++. I found out that recently you can store Helm charts in Azure Container Registry. So I was architecting a small project recently where we were looking at deploying a Kubernetes application using Helm, right? So I thought that we'd have to build a separate chart repository to be able to host these Helm charts so they can use to deploy our Kubernetes deployments. But I found out that the Azure Container Registry, also you can push Helm charts in there. So that's a kind of bonus. If you're looking at Helm charts or you want to know more about stuff, like you can ask me in the Q&A. But yeah, I found out that the Azure Container Registry can also hold Helm charts, which is a win-win, right? Also, it integrates with Active Directory, so you can control permissions using Active Directory. Here's an example of what it looks like in the portal. So this is looking at an actual image in the portal. Pretty straightforward, right? So if you've got one image, you've got the image name and the version there. Tells you what repository it's living in, bit of details on it, the tag, and then it gives you the Docker pull command. So you can kind of copy that, paste on your machine, and it will Docker pull from this registry, provided you have the right credentials. It will pull from this registry to your machine. So that's kind of what it looks like. Pretty self-explanatory. If you set up a container registry, you can view images like this. This is how you log in to log into a registry. So super easy. You just say Docker login, boom, and then wherever that registry is. So registries give you a public URL. So if you want to, obviously you can make it private. They give you a public URL. You can just say Docker login that URL, provided you have the credentials, you're logged in from any machine. And then you can start listing what images are in there, and off you go. Or you can perform builds against the items that are in the repos. So that's kind of easy, super easy to work with. I think some people find like working with Docker kind of intimidating, but once you try a few things and work with it, actually it's kind of simple. The concepts are difficult, I think, but when it comes to the technical components, I think reasonably straightforward. So what's Azure Container Instances? What's ACI? So ACI is basically your Azure's offering for unorchestrated containers. So kind of it's like you can actually spin up containers on demand. It's like per second billing, integrates with other Azure services. You can get a public IP for your containers. They support Windows and Linux. It's essentially your containers as a service. So it's a managed service provided by Azure where you can just spin up containers, unorchestrated, just sort of living in the cloud, and per second build for whatever. So let's say I'm doing dev and I wanted to spin up a container to quickly crunch some numbers or whatever, and then I'll be done with it later. I just spin up a container in ACI. I don't have the overhead of orchestration. I just spin up a container, do what I want with it, and shut it down. So it's almost as easy as spinning up on your machine. So spinning up a container on your machine, spinning up a container on ACI. Actually, I won't say almost, I'll say is as easy. And yeah, it's super useful for your dev loads, for your stateless loads. Azure Container Instances is super cool. So it's the same as running Docker on your machine, just in the cloud. You don't need to provision VMs, clusters, whatever. You just provision containers and be done with it. So that's sort of a unique offering, which I think is pretty cool. So here's the example of how to create a container on Azure Container Instances. 2 commands there. It has AZ group create. So that's just creating a resource group in Azure. If you're not familiar with resource groups are just a way of grouping all your resources. So it makes sense, and it's compulsory that every resource you create, whether it's a container instance, a virtual machine, networking components, a database, etc., they all live within a resource group. Now, a resource group could be a way of separating departments' resources. Let's say you've got a sales department, a marketing department, etc., for billing, or it could be just a way of organizing your stuff into like maybe Singapore resources, resources used by Singapore, resources used by Indonesia, etc. So it's just categorizing your resources. And then the second command is that's it. This is how you create a container. It's using the Azure CLI, container create, passing in the container name, whatever you want it to be, the image that it's getting it from, resource group, as I said, and then just setting the IP address to public. So that's a very simple example of how you can create a container in the cloud. That actually will work if there is an image out there called Microsoft Hello World. So that will probably work if there is one out there, but it's super simple. Okay, so hold on a minute. Okay, so let's go back to Tailwind Traders. Right, so Tailwind Traders, that's our fictional company that we were looking at before in the previous talks. They've gone through a big series of growth. Tailwind Traders has now come to agreement to purchase Northwind. Northwind is another fake company. If you're familiar, if you worked with Microsoft tools before, Northwind has been around for a while. So, you know, if you're a fan of these successful companies, now there's a successful company, successful fake company merger. We're going to talk about what will happen to Tailwind or Tailwind/Northwind, you know, when this merger happens. Right. So let's give a practical example of, you know, when you would want to use containers. Right. Okay. So there's lots of money with this deal. There's a fake company, etc. But the company has one new mandate. The new mandate is save money. Okay, so this is Jill. Jill is the newly minted kind of CTO of this conglomerate fake organization. So Jill has come with a mandate and informed the IT department that the following must be done in order to see greater profitability and reduce overhead. So there's a mandate coming from the boss related to this new company. Let's see what they need. Right, so they've got a migration path. They know what they want to do. So they're suggesting we move to an elastic solution. Okay, so something which can scale up and down as and when needed. Looking to reduce the responsibility for the team, offload to services. Okay, so don't want people managing data centers, etc. So needed to grow and scale. Okay. And looking to modernize for more rapid development using containers. So looking to modernize the way we do development so that we can focus on delivering features. Okay, cool. Sounds like a good mandate. Right, so looking at the Tailwind Traders app currently, what does it look like now? So they've got multiple VMs. They've got a MongoDB with no SQL data in it. Okay. That's their semi-structured data. So they've got MS SQL for the structured data. Okay. .NET Core on the back, React on the front. Okay. Looks pretty well. Multiple VMs. Not sure what that means yet. Okay. So the work ahead of these teams is to migrate all this stuff off VMs into containerized applications. So that's how we're going to manage that growth. And it's going to help the team reduce the day-to-day work of operations, day-to-day work of managing machines, and provide a much more rapid and streamlined method of deployment. Okay, cool. So we understand where we are. We understand what the mandate is. Let's see how we would do it. Right. Okay. So I had a couple of decisions along the way. I thought, okay, what's the best way to do this? Let's look at Azure App Service. So Azure App Service is a managed service. I talked about this in the first talk in the session. Basically, it's a fully managed application platform where you can build and deploy your application code. And it will run in the cloud. Underneath, it runs on VMs, but you don't need to manage those VMs and the OS and the patching, etc. You just deploy your code to wherever that may be. You set your configuration values, and there's a URL, or you expose whatever ports you need, and the application will run. So that's a managed service by Azure. Very, very cool. I showed the deployment slots thing earlier on as well. That was super cool. So this removes the need to manage operating systems, etc. You can deploy your stack natively. One of the things it doesn't say there is that it supports, which I'll show you, it supports Docker containers as well as building from your application source code. So I'll give a demo of that later on. Azure App Service supports building from your source code, but also it's called Azure App Service for containers, but essentially it's the same thing. You can host your containers running in the app service with all the configuration values, et cetera, you can scale. We're going to go with Cosmos DB. Cosmos DB, I'm a big fan. It's Microsoft's globally distributed multi-model database. It's going to replace what they were using on MongoDB on a VM. We know that porting from MongoDB to Cosmos is sort of a one-for-one. You can just switch it over. So why host Mongo in a VM where you have to manage the Mongo instance, etc., where there's a managed service, you can just plug straight into the managed service and be done with that as well. I'm a big fan of managed services. Rather, if there's a managed service out there and you don't need to manage the machines itself, that's the way that you should go. Unless you're in the business of managing machines, then by all means continue. But if you're in the business of building an application which solves a problem for users, you don't want to be spending your time focusing on managing the infrastructure. Cosmos DB, it's a multi-model database. I talked about this in the previous talk, but if you weren't there, there's MongoDB. Cosmos DB is a NoSQL database, which you can interact with directly, but there's a bunch of different APIs on top of that, like a MongoDB interface, a Gremlin interface, SQL interface, where you can interact with the Cosmos database using these interfaces. So that's kind of one of the big ticket items when it comes to Cosmos. I talked about that before, but if you are not familiar, do check it out. We're using, for the structured data, we use Azure SQL. So again, moving off the VMs, SQL Server on a VM, again, another big hassle you have to deal with as a managed service. If you don't have a DBA, then you need someone with kind of DBA-like skills or someone who's interested in that to manage the stuff on a VM. 10 years ago when I was working, there was always a DBA on every team that I worked with. Now, I haven't worked on a team with a DBA for ages, right? So, and part of that is due to managed services, right? So you don't need that DBA resource, and they're probably getting harder and harder to come by now. I don't know what kind of pays they're asking for, but probably a lot because they're rarer. We'll move to Azure SQL. It's scalable, auto tuning, which is auto DBA, which I think is definitely go that way. Right. So the migration path. So what we're going to do is we're going to containerize the app. So take the source code and put it into a container. We're going to create an Azure container registry. We're going to build and upload that app into the container registry, and then we're going to deploy that container using Azure Web Service. So this is the migration path. I'm going to give a demo of this part. So creating an image registry, building and pushing an image into that container registry, and then deploying that application using the Azure Web App Service. Right. Okay. Cool. So let's build a container. Okay. So if this is my portal, my web portal for my Azure portal, but what I'm going to use today to do this is the Azure Cloud Shell. So I'll just reconnect. If you're not familiar with Azure Cloud Shell, you go to shell.azure.com, and what it does is it'll automatically log in with the same account that you've been using for the portal. So this will log me in here, and I can use this portal to interact with my items running in Azure. So we've just cancel. Okay, cool. So if you go AZ here, AZ, you've already got the Azure CLI here available because it's already pre-installed here. And my favorite command, azvm list, it will list out the VMs that you have in your subscription. Right? So, let's just make it a little bit pretty. So this is just listing out, I've got one VM in there with this complicated name, but that means something to someone. Right, so first of all, what I want to do is I'm going to pop in some environment variables, which I'm going to be using later on. I'll talk about this in a moment. So just I'll be using these as we go. First of all, what I'm going to do is I'm going to create a resource group. I mentioned before, I want to create a new resource group because I don't want to, if you look in my subscription here, I've got a whole bunch of resource groups. All these resource groups, and I don't want to get this new thing mixed up with that. So I'll create a new resource group, off it'll go, and I've got the resource group here specified. You can see here as a resource group. I call it apps 30 RG live. So it's created a new resource group, which will be available in my portal in just a second. Next thing I want to do is I want to create that Azure container registry. So to create a container registry is just ACR create, boom, with my variables that I popped in here earlier. So resource group, I've got the name for this container registry, the location, etc. So Actually, whenever you create something using the Azure CLI, it spits out a JSON description of what you created. So this tells you all the details of what you created. You can take and you can keep that for reference purposes. Also, you can take that and you can use this stuff for helping to create your ARM templates. If you wanted to rebuild your infrastructure and use infrastructure as code, you can take this output and use this to help build up your ARM templates. So I think it's always nice that you get that feedback. Right, so now I've created my container registry. So let's just keep going. Okay, so I'll run some commands here and I'll talk about it in a second, right? So first of all, what I want to do, now that I've created my container registry, I want to fetch some code, right? So I'm going to fetch the code directly from the Microsoft Tailwind Traders website. So it's straight up from GitHub, Microsoft Tailwind Traders website. I've just cloned that repo, and I'm going to build from that code repo and push it into the Azure Container Registry that I just created. So I've cloned the repo. I can already see that the first step of the process has been done. So the application code has already been containerized. What I'm doing here is I'm building. So if I look, there's already a Docker file in here. So if we look at Tailwind Traders web, I've just fetched from there. There's already a Docker file. So the application's already been built, kind of Dockerized. We're just going to take it, build it, put it in the container registry and deploy it out. So, but it's still in source code, right? So no one's done that yet. So what I want to do is I want to do this. Okay, just 1 second. Okay, so it started. So this will perform the build. I want to tell you guys about this because it's super cool. So normally if you're building an application, you need a build server. You need somewhere to provide that build. So it's either you're on your physical machine and your physical machine does the build, or a build server and the build server does the build. With Azure Container Registry, it provides the ability to build through Azure. Like, so if you have an Azure Container Registry, it comes with an additional kind of add-on, build add-on, so you can build against that using that Azure Container Registry. And behind the scenes, what happens is Microsoft will spin up a little container, it will do the build, and it will send it off. But using Azure Container Registry, you can build directly by using an AZ command. So that straight away eliminates that, build was done on Jeff's machine, build was done on Jacqueline's machine, and there's sort of a mismatch in the build because of the configuration. You can build directly against the cloud, and over there it will build for you. It will build the application for you. You can see here it's starting to build. It's downloading some images. It's doing sort of what was in the Docker file. Looks like a Node application. It's going to be compiling some Node, doing some stuff. So all the stuff that was defined in that Docker file that I showed before. But yeah, I think that the fact that you can build from the command line at Azure, that is like, for me, it's a bit of a game changer. It might seem like a simple thing, but for me, it's a bit of a game changer because I don't like to have to manage my builds either, right? Like, I don't like to have to manage virtual machines. I don't like to have to manage the build server. I don't like to have to manage anything if I don't have to. There's a managed service that does it. I can focus on building features, or my teams can focus on building features, and all this stuff can be delegated away. And for Azure to provide that little service, that build service, with the container registry, that makes my day, right? So it's consistent build, just run over there, be done with it, So I think that was a super cool feature. Thanks, Azure Container Registry. I think it's a super cool feature. If you're building your application, just build it there, save your VMs. Let's have a look. What else did I do here? Let's have a look, just in case there's anything I missed. So I had the build. It does this. I fetched the code from Tailwind Traders. I created the Azure Container Registry, and I created a resource group. So I think it's still building. I think it will take a little bit depending on the type of application. But let's have a look and see if my resource group is there. So I'll refresh. Right, I created the resource group apps30rg live. If I go in there, sure enough, I've got my Azure Container Registry. So let's have a quick look at the container registry. You can see here, this is what it looks like. You can see repositories. Repositories will be where your images will live. It's not Image not there yet. But you can actually set up, another thing interesting you can set up is replications. You can actually replicate your container registry to different locations. So let's say I've got, I'm building and I'm deploying to my containers in Singapore. I'm deploying to my container registry in Singapore. And I have one deployment in Australia and one deployment in Singapore. Or maybe not, maybe it's too close. Maybe one deployment in Singapore and one deployment in South America, right? So if I had only my container images in Singapore, when I deploy to my Singapore application, it'll be fast, right? It will just pull the images from within the data center. But if I am deploying in my Sao Paulo, South American instance of Azure, it would have to pull the images from, all the way from Singapore. And I've seen images get large. So I've seen images, sometimes they're very small, few megs. Sometimes your images can be huge, maybe like a couple gigs, right? Depending. I worked on an application where in the image, it had a world map. So this world map was in the image. It was a map service. The world map was in the image. It was a large image. And, you probably don't want this 2 gig image to have every time you deploy, especially if you're looking towards like continuous deployment, deploy multiple times a day, right? So you can actually replicate your image locations. So you can set it here, you replicate this container registry over there, creates a cache of your images there. Also, one of the things that I've done often as well, I often create a cache on my on-prem environment for the devs, right? So the devs, often they're constantly pulling and deploying to their machines. One thing you might want to do is create a cache in your office, perhaps, and then so it doesn't always pull the images from as well. So that's another thing about that. Right. Okay. So let's see. Okay. So that's finished building now. So now that my image is built, I should be able to see it in here. Okay, so I didn't mention, but when I created it, I specified a name. I called it TWT app, and I gave it a tag number. So I might rebuild later and give it a separate tag, or yeah, I can do that. But essentially, I've got this repository here, and this is what I showed earlier. It's got the tag, and that's the image. So I want to deploy this application now. So what I'm going to use is a web service, a web app. So I've got this thing. I want to add a web app. Right, so I'm creating a web app, putting it in this description, in this resource group. Let's just call it Tailwind website, because that's what I, or maybe it's used. Let's put some numbers. Right, so when I publish it, I want to publish it not from code. I want to use a Docker container. The region, I think, doesn't really matter for now. It's a test version, and same with the app service plans. So that's all okay. You can change your service plan if you need it. But the main point here I'm trying to get across is we're publishing from a Docker container. Next, we want to choose single container, not Docker Compose, so because we're going to be building a single container. The image source will be Azure Container Registry. Okay, and the registry we're going to use is the one that I created here, the apps ACR30 live. And if we have a look in there should be that image. Sure, there's that image we just created, and there's the V1 we just created. So you just review and create. One second, create this. So this will be deploying that app. Right, so now the deployment's in progress. I actually like this. I like that when you deploy, you get that instant feedback. It's showing that, okay, the deployment's in progress, and it will show you individually the items that get deployed. In our case, it's a web app. It should be reasonably straightforward. So yeah, it's just creating the servers underneath where the web app will run. Should just take a minute or two. And yeah, so just to recap, what have we done here? So we created a resource group, created container registry, built from the Tailwind Traders live code. There's a Docker file in there, built that Docker file, and now we're running that Docker file, running that container from the Azure Container Registry in Azure. So have a look at this resource here. Okay, sure enough, and then it's got a URL. It's already exposed. So if I open this up, it should be running. This takes a second. Okay, that's the right one. Don't film now. So this is, yeah, that's right. So there's got this, the URL exposed. The container might be starting up here. Oh, actually, one of the things I missed here was container settings. So if you look at the container settings on this website, this is the web app service. Looking at this app service, normally there you have the configuration values, which I showed before. And then you go to container settings, you can see that, okay, the image is coming from Azure Container Registry, this registry, the image, the tag, etc. You can see all the details, and also you can see some logs. Let me just refresh this. I feel like it's not, that was something. So, yeah, okay, so there it is, so it works. So this is a live website pointing to this app service, which is now running a single container. Cool. Okay, so just winding up here, back on the deck. So yeah, so that was the demo for this for containerizing application. If you notice, I didn't really discuss Kubernetes. If you've heard about containers or you're talking about containers with people, you probably hear the word Kubernetes coming up a lot. It's definitely the most popular container orchestration platform at the moment. So the reason I didn't talk about Kubernetes yet is because the next talk, Apps 40, is dedicated to Kubernetes. I'll be talking more about what Kubernetes is, what Azure Kubernetes Service is, and how that works. So that will be the next talk. Just to summarize on this one, we talk mostly about containers, how containers can benefit you, how Tailwind traders can move to a containerized environment. I hope you gave you a bit of a summary on what containers are and how they work. Cool. So thanks very much for listening to this talk. Just to let you know, there'll be a quick break now between talks 3 and 4. So yeah, go ahead, grab a break, chill out, have your coffee or lunch or whatever you do, and then I'll see you again for Apps 40, where I'll be talking more about Kubernetes. Thank you very much for your time today. Hi, welcome back. Hope you guys had a good break. This is the fourth talk in the series. Still talking about developing cloud-native applications. I'm Andrew Whiteside. If you don't remember me from the last talk, I'm the coach and mentor when it comes to developing cloud-native applications. Right. Okay. So had a good break. Let's get cracking. Let's get started on this fourth one. We're going to be talking about consolidating infrastructure with Azure Kubernetes Service, so AKS. This one is pretty exciting. Definitely the whole Kubernetes ecosystem is really exciting at the moment. People are looking at containers. Kubernetes is definitely the front runner. It's a very interesting topic. I think people find it a little bit confusing. So hopefully I can make it a little bit less confusing for you. That's really my goal today. Right, so the agenda. We're going to be looking at Tailwind Traders again. So the Tailwind Traders app, based on Tailwind Traders and what they need, I'm going to be talking about a little bit of introduction to Kubernetes and the components of Kubernetes. We're going to talk about scale, about how to scale your different options you have for scaling your applications in and out. We're going to talk a little bit about network and security, pod identity and Calico network policies. If you're a network guy, you'll understand that stuff. If not, I'll give a high-level overview as well. And talk a little bit about handling failures. So sort of what cluster and error management options you have when working with Kubernetes. Right, so let's get cracking. We're going to talk a little bit about Tailwind Traders again. So, I'll be using them as a reference or a case study for the rest of the talk. Right, so Tailwind Traders components, we talked about this in the last one. So Tailwind Traders have got a mix of different bits and pieces that it takes to run their application. They've got a Postgres SQL database for their structured data. They've got SQL database. They've got some virtual machines here and there. Everything's running on virtual machines. They've also got some container instances, which we talked about before, which they're running on, and they're using blob storage for their unstructured data. So they've got pretty much a nice mix of everything, reasonably complicated architecture, but also kind of standard kind of architecture that you'd have with most kind of modern applications these days. Right, so, we're looking at progressing this application. We're making it more progressive, making it more maintainable, scalable, moving a lot of stuff to cloud to manage services because, like I said before, they're not in the business of maintaining their virtual machines, much like I'm not in the business of, building my own car to get to work. I just want to drive it and get to work. These guys will just want to make features which are beneficial to users, right? So management got some abilities that they've come to us and asked for. So they want resiliency. Resiliency is actually provided by Kubernetes itself. So Kubernetes at its core, what it does is it restarts your services. If you have a deployment that says this service is there, you delete it, it will restart it for you. So resiliency is kind of built into Kubernetes, which is cool. We'll look at security. That's something that's also important to Tailwind Traders. So we're going to look at how we can implement some security for the application. Flexibility. So they want to be able to deploy to different kind of availability zones and networks and scale. So flexibility is there. And also scale. So they want to be able to handle the scale when it comes. Well, I talked before about data centers. Like, if scale comes, you're like either panicking because the data center can't handle it, or you need to assume what the scale will be and potentially overbuild your data center. They want to be able to scale like as and when needed. So that's what scale is really about. You want to be able to get the load is high, scale up. The load is low, scale down. And that's where you can really maximize cost. So why Kubernetes? What's the point of this thing, right? Why would you even want Kubernetes? So Kubernetes essentially is a standard API for infrastructure abstractions. Kubernetes allows end users to have a standard API to interact with the infrastructure, so they don't need to worry about actually manually provisioning resources or cloud services like public IP addresses, load balancers, etc. Kubernetes provides that sort of infrastructure as a whole, so you just interact with Kubernetes. You don't have to interact with all these sort of many components all over the place. Self-healing, that's one of the major things, self-healing out of the box. So if you have a service that runs up, for some reason that service crashes, something wrong with that pod will crash, Kubernetes will bring it back to life for you, right? So you can actually, if the pod shuts down and then finds that, okay, there must be at least one instance of this pod running, it will spin up the pod. Yeah, so Kubernetes has that out of the box. Scalability, so there's a few options to scale with Kubernetes. You can scale applications, but you can also scale the cluster. I'll talk about that in a second. And extensible, right? So Kubernetes has a lot of different plugins now. Like so Kubernetes, the ecosystem is, it's very, very busy at the moment. So there's a lot of plugins that are being added to Kubernetes. It's being extended. There's a lot of documentation. There's a vibrant kind of ecosystem. If you're interested, there's a lot of Helm charts which you can use to deploy additional plugins to your Kubernetes cluster. If you go to like helmhub.com, it'll show you like a whole list of Helm charts that you can use to deploy additional plugins into your Kubernetes cluster. Like I was recently working on one myself. I won't plug it just now, but it's also a very, very cool ecosystem. So a lot of people are working on this stuff, and a lot of the stuff's open source. Kubernetes is open source, by the way. Okay, so AKS architecture. So what does it actually look like? When Kubernetes is running, what does the architecture look like? Oh, okay, so Kubernetes, I'll give you a 5-minute summary on exactly the Kubernetes architecture. So Kubernetes, how it works is there's a concept of master nodes and worker nodes. Now, master nodes contain your control plane. So it's all the orchestration and running components of your Kubernetes cluster. So that's called a running on a machine. In Kubernetes, the machines are called nodes. So a node is like a VM, I guess. So Kubernetes, let's say you have, if you're running Kubernetes on 5 virtual machines, or 5 physical machines if you wanted, you'd be running it on 5 nodes, and you have to have the master node or at least one master node, right? So if you've got 4 machines, you might have 2 master nodes for high availability perhaps, and 2 worker nodes, right? So the difference between a master node and a worker node is master node just contains the infrastructure to run Kubernetes itself, and worker node contains your actual application code. So your application code runs on the worker nodes and the Kubernetes stuff on the master node. If you look at the architecture here, the master node contains an API server, which is like how all the worker nodes integrate and connect with Kubernetes. There's also a scheduler, which is responsible for scheduling the pods, like when the pods run, if one shuts down, to schedule a new one, to maintain like at least 2 pods are running of this particular application or website. So the scheduler does that. And the controller manager manages the replication, service counts, make sure that, there's all these services available, like a service exposing a web URL, make sure that that's all there. So that's all done in the master node. It also uses etcd as a database on the back end. And that's how the sort of master nodes work. Worker nodes is essentially all of your Docker, your application code gets deployed to worker nodes, and that's where it runs. There's you can see there's something called kubelet. Kubelet's a daemon set that runs on every node, physical node in the Kubernetes cluster, that allows that worker node to interact with the control plane, the Kubernetes control plane. The thing about Kubernetes is that actually this stuff's a little bit complex. I can see, even looking at this diagram, understanding that master node and how the master node works is complex. And I've been working on teams where we've deployed and ran Kubernetes ourselves in-house. We've done it on physical hardware, on cloud stuff, and maintaining that master node and all the components in the master node. And, ECD gets out of sync, and then we don't know how, and then digging into etcd requires a very specialized skill set, which maybe I don't have, or maybe my team doesn't have. It's a little bit complicated to work with, right? So as much as Kubernetes brings a lot of good things when it comes to resiliency of containers, scalability, etc., managing the Kubernetes yourself is a bit of a hassle. So this is where AKS comes in. So AKS is a managed service provided by Azure, where all the control plane or management of the control plane is handled by Azure. So, back to my point, I can't stress this point enough, right? So, I wouldn't build my own car myself. I'd be crazy to, because the cost of me building a car, because I don't know anything about cars, or I need to get somebody who knows about how to build a car, and I need to buy I don't even know. Where do I get the engine? Okay, but what do I get the other parts, and how many parts do I need in the car? Like, I don't know, right? So I would never invest in building a car, even though the initial, if I looked at buying a car, I'm like, okay, it's expensive, right? But if I think about it, building it myself is probably going to be much more expensive. Yeah, so that's why I think managed services are always the way to go, because there are experts out there like Toyota or Mercedes or whatever. They're experts at building cars. They build cars, and I focus on driving my car to where I need to go. Right. So same concept here. AKS is where Azure provides you that control plane, and all you need to really take care of is your worker nodes, where your applications are going to run. Right. So if you look at the architecture here, there's a user. You've got the workload definition. You interact with Kubernetes, so you deploy a workload to the Kubernetes API. All this control plane stuff is managed by AKS, and you can just see on, for example, here there's one VM, and it's running, or maybe that's 1, 2, 3, 5 VMs, say 5 nodes running, Kubernetes on each of these, right? So you've got just your worker pods. So that's very, very cool. So all the operational tasks, actually even on the worker nodes, the AKS is responsible for the underlying operating system of the worker nodes as well. So OS patching, all that sort of stuff, it's also handled by the AKS service. So again, focus on your application. This is what it looks like from a networking perspective. So in AKS, you'll see that there's an app gateway. So again, you can see the control plane that I was talking about. So the master nodes, the physical master nodes here hold that control plane. That control plane contains, some DNS service, which allows the pods to be able to talk to each other if they need. And also external, can expose external URLs or applications to the internet, right? So say you've got an internal load balancer in Kubernetes. There's the ingress controller, which helps you to route the traffic from outside into the Kubernetes network. And that's living in the control plane managed by the AKS service. So again, you can see there's the kubelet running on each worker node. So here I've got, you can see the control plane. You can see 2 worker nodes. You've got one worker node, which is essentially a VM, think about it that way. A worker node, which contains the containers. This one's got 3 containers running in a pod, but interesting. So one pod running 3 containers, another pod running 3 containers, and the kubelet daemon set. There's a little cat in between there that represents Calico. So Calico, I'll talk about a little bit later. That's kind of one of the options that you have for networking on Kubernetes. So how the networking is actually handled within AKS or also within Kubernetes. Right. So AKS. This is an interesting concept, right? So this is new. It's unique to AKS, where you have the concept of a virtual node. So remember how I talked about like each node is actually a virtual machine, and you have your Kubernetes master nodes, which is in this case handled by AKS, and then you have your Kubernetes worker nodes. So worker node is like a physical VM, 1, 2, 3. You've got, say, 3 worker nodes, and they all run kubelet on there, which is a daemon set, which allows it to connect to Kubernetes, and then has all the workloads are then published to these machines, right? So that's 3 sort of VMs. Now, in Azure, there's a concept called virtual node. So rather than having a physical node, you create a virtual node in your Kubernetes cluster. So you say you've got 1, 2, 3 physical nodes, 1 virtual node. And inside that virtual node, you just spin up independent Azure container instances. So separate ACI instances. Now, that concept is super, super cool. So you can have like your 3 physical nodes, which have limited scale, right? So you've got 3 physical machines, they have whatever size machine you choose, their scale is limited. Yeah. But if you have a virtual node, you're just running these independent Azure container instances in there. So the scale is kind of unlimited, right? So you have one virtual node, you can just pump as many individual containers to run on this virtual node, and it will just scale forever. All you need to worry about is obviously the permanent charging, right? So it's perfect for your stateless services. So if you've got some video processing is a good example, right? So let's say you've got some TikTok or whatever, you're running TikTok, right? So TikTok has got people upload their videos, it probably encodes their videos into different formats so that they can be reused, right? So let's say you have your main application running on 3 physical nodes or 3 Kubernetes worker nodes, and then you have a video processing service. So every time a video gets uploaded, it processes it into like 8 different formats for different phones and whatnot. So you might have that processing service running as separate little Azure container instances. So every time a video uploads, spins up one pod and then does the processing and finishes, right? So if people uploading billions of videos, you can just scale out or pop for this encoding, and then they shut down when they're done. So it's only paying for the load you're using, right? So that's a super cool architecture. If you know that you don't need to implement it, that's not relevant for every project, I guess, but knowing that it's there is super useful. So if you can get your application to have a lot of stateless services, you can pump them out to ACI and sort of scale out crazily, right? So think about that when you're designing the architecture of your application and thinking about how that can work for you. It's I think it's super cool. If I'm working on an application in Azure, I'd definitely be looking at this in conjunction with the standard stack of Kubernetes, right? Right, so here there's also the concept of availability zones. So in AKS, first of all, there's availability zones. So each Azure region has a concept of availability zones within that region. So that's for redundancy. So your load can be split across worker nodes that are in different availability zones. So let's say you have 2 worker nodes in availability zone 1, availability zone 2, and availability zone 3. So you have 6 worker nodes. You can actually set your application to split the load across all of those, and then for some reason, if availability zone A goes down, then the load will automatically be spun up on availability zone 2 or 3, right? So your application is highly available because it will move the pods around, right? And that's the beauty of Kubernetes, right? So you got 3 machines, and you just go and kick one machine over, and there's 8 pods running on that machine. Kubernetes will automatically go, hey, that node's available, let's spin them up over there. So availability zones is built into AKS as well. There's also you can also build it up across regions. So across regions, you can have different clusters in different regions, making it highly available, right? So you can use Azure Load Balancer for that. You can do more reading on Azure Load Balancer, but you can balance your load across different clusters in different regions as well. But availability zones is super cool, and you use that using node groups, I think is the term. Right, okay, so I'm going to show you, I've actually got in this slide deck, the step-by-step commands on how to create your own AKS cluster. So I'm just going to walk through it a little bit. You can actually take these slides, when I finish the talk, you can take these slides with you. You can use these commands to spin up your own Kubernetes cluster and do some testing. I've got step-by-step the commands that you execute in order to spin up your own kind of cluster. So that's nice. First one is creating a group. You always create a resource group. Remember I mentioned that before, that everything lives in a resource group. You just set the resource and the group, that's it. Holding all the resources for our cluster. You create a VNet. So a VNet is a network, so the network where your Kubernetes cluster will live. So you've got your resource group, which is where the grouping the resource, and then you've got a VNet where the network where the Kubernetes cluster will live. Here's I've just specified some parameters there. We also create a subnet. So the subnet is used for communication between Kubernetes and the ACI API in the region of the cluster. So we add it to the same resource group, but we use the subnet so that you can communicate, so Kubernetes can communicate with the Azure container instances. Yeah, so that's the reason of the subnet. So there's one big network, and there's a subnet here in the Kubernetes, so that there's 2 subnets where the Azure container instances live and the Kubernetes cluster lives. Next, you need to create a service principal. So the service principal is basically a service user so that the cluster can access external services. So let's say you've got your cluster, right? But then the cluster is also accessing a Cosmos DB or a SQL Server or a PostgreSDB anything else in Azure. So you create a service principal. So that can be used to access resources that are outside the cluster. An example for this would be like a public IP address to schedule pods on ACI for virtual nodes, right? So that would need the service principal. So actually, if you're not familiar with the service principal concept, it's just an object which gives roles and permissions to other objects. That's it. So service principal is if you worked with Active Directory, if you worked with users and roles and IAM before, you'd be familiar with that. But service principal just allows you to give roles and permissions to other objects. Right. Okay. So this is the command. So of all the setup stuff that we had there, the command here. This is the command to create an AKS cluster. This is to highlight the very simple test cluster command. If you're spinning up a cluster, all you need to specify is resource group, the name of the cluster, node count. So remember I had how many nodes your Kubernetes cluster will be, how many VMs, and generate SSH keys just says that it'll be generating its own SSH keys when, and it will give them to you so when you access it via SSH. This is definitely the simplest way to do it. It's super easy. It's doesn't have a lot of detail, and you can create a cluster like this. However, there's a lot of other configuration values that you really need to consider when you're creating your cluster. So this here is for maybe a test or a demo setup, but I wouldn't be using this for a cluster for a production setup. I'll talk about a little bit why. So this is kind of probably what you would want to specify when you're creating a production AKS cluster. So here I've got, I'm specifying the resource group. I give the cluster a name. Okay. I'm specifying the node count, which I talked about. Using the service principal, so that's that service principal. So this is the service principal that Kubernetes will have to be able to access other resources. I've got client secret, so I'm generating SSH keys. I'm using the Azure network plugin, which allows CNI to to create network policies, and we need that. Like, it's a prerequisite. We need the network plugin so that we can create network policies. We've got a DNS service, which we need to use for internal service discovery, so that when a new pod comes up, new service, then they know where they are. So that's something also you need for a production setup. So Docker Bridge has an IP address, IP range for Docker to start. Otherwise, like, systemd will fail if it doesn't have that. So that we can have a Docker Bridge. We had a VNet of that subnet that we talked about before. We had a load balancer. So this is so that we can, if you want to enable availability zones, you need to have a load balancer in the cluster so it can balance out between the availability zones. VMSS is saying that, okay, cool. So actually there's a couple options for, like, when you create your worker nodes. So you can create your worker nodes like using individual VMs. So you can say, okay, cool, this Kubernetes is going to have physical VM, or VM 1, 2, and 3, and that's it. Now, another option is you can use virtual machine scale sets. So you, rather than a VM, you have a scale set, which I demoed in the first talk. And you can actually set it to, like, automatically scale up more more nodes as and when needed, right? So a scale set makes it a little bit more scalable than having physical dedicated sort of machines attached. Node zones 1, 2, 3. So it's saying, okay, split the nodes amongst the different availability zones. And network policy. So you need to choose the network policy when you set up the cluster. So one of the things that it might not be totally. You kind of assume it, but it's not right. Is that some of the things actually would need to be defined when you create your cluster. So if you went ahead with that simple approach that I showed before, and then you wanted to change the network policy of your cluster, actually you can't. So you need to have a bit of a think about, what's the future of your cluster look like. Make sure that you build in a little bit of future proofing to your cluster. So, I think when it comes to setting up Kubernetes, you need to have a think about, what is the network policy you want to use and why, and make sure that that's built in when you build your cluster, and make sure that you future-proof your cluster a little bit. Because once you have a cluster running, which has one network policy and you've got production loads running on it, you can't change it without deploying a new cluster. So that's something to definitely take note of. I think a lot of people will learn that the hard way. That you just spin up a simple cluster. I'll be able to change that configuration later when I need it. But with the AKs and the Kubernetes setup, some things need to be defined up front. So do think about that. Here I'm adding the virtual node. So there's a virtual node add-on that allows me to add that virtual node I talked about, where you can scale unlimitedly with ACI instances running in their own virtual node. Just got the cluster, the add-on here, putting it in that subnet that we created, and adding it to that resource group. Right. Okay. Well, this is a slide which tells me, brings up that point that I was talking about a minute ago. Future-proof your cluster by enabling virtual node. You can't do after either. CNI and availability zones. You can't do it after the Kubernetes cluster has been created. So you can only enable the virtual node when the cluster is created, and same for CNI and same for availability zone. So you can enable it, but don't use it. But I'd say probably if you're thinking that in the future you might need this stuff, then I'd say turn it on when you do your cluster. Just to avoid yourself problems, you can't really retrofit, the networking, the availability zones, and the virtual nodes. So you can turn it on. It doesn't hurt to have it on, but you think about it at the beginning. Okay, cool. So next, I'm going to talk a little bit about scale. So how Kubernetes handles scale and how scale works. Okay, so let's say we've got this feature request from management. So management are asking us for a new service. The new service must generate customer recommendations. So a customer recommendations engine, right? So service must have its own deployable artifact, must have documented APIs to interface with existing services, right? So basically, they're looking to create a new service, customer recommendation service, document API, and it must be its own separate deployable artifact. So you want to be able to deploy this service independently. So here's a solution that we've come up with. So this is something that can solve that problem, right? So we're going to create a new service, customer data service, which takes data from RabbitMQ, and then processes the data, and then pops it probably back, lives in there. So think about your recommendations engine. So anytime someone makes an order, it just pops an order onto RabbitMQ. This service here is just consuming those orders and then doing some recommendations engine stuff. So if someone orders a Netflix video, this customer service would then look at that video, look at similar videos, okay, cool, and then update the kind of recommendations for that customer. So that's kind of imagine what this system is doing. Right, so and also they want it to be scalable. So let's say, there's it's with Tailwind traders. There's like many different orders coming in at the same time, and it's too much for this customer service to handle. They want it to be able to scale so that you can have many services updating many recommendations into at the same time. Right. So here's a couple options that come out of the box with Kubernetes. So one is called Cluster Autoscaler. Now, the Cluster Autoscaler watches for pods that cannot be scheduled because the worker nodes are full up with resources, yeah? So if you look at this diagram here, you've got, okay, let's say we've got a new deployment, there's a couple pods. The pods are in the pending state. So there's different states for pods. They're like pending, running, pulling, they're different states for the pods. So let's say we've got, in the cluster, we've got 2 machines, and those 2 machines can only fit 2 pods on them, right? Because they're, got so much memory and so much CPU, etc., right? And the limits set on the pods are, they consume up the whole machine. So let's say there's a new deployment, 2 new pods need to come in, and they can't fit on machine 1, and they also can't fit on machine 2. So they're kind of like just stuck in this kind of stale state where they can't be deployed to either of these machines because there's not enough resources. So what the Cluster Autoscaler does is it watches for pods that are unscheduled because there's no resources available, and it spins up an additional node in the cluster, right? So say you've got 2 VMs, running in the cluster. The cluster autoscaler will go, okay, hey, these 2 pods are waiting, add a new VM, and it can schedule those 2 pods to run on that machine. That's how it works. Also, what it does is if it finds that, one particular node is underutilized, so there's, all the pods are scheduled on, machine 1 and 2, and machine 3 is not being used, cluster autoscaler will scale it back in so that the nodes are not there. So cluster autoscaler is your vertical scaling, where it adds new machines if the pods can't be scheduled. So you can read about cluster autoscaler in docs, but that's one of the options for scaling. So scaling, adding out new virtual machines. You've also got HPA, which is horizontal pod autoscaler. So this is the scaling technology which is mostly used by applications. So not for the physical nodes. The physical machines are okay, but that particular pod is consuming a lot of resources, or there's a lot of demand for that pod, and then you want to have 2 versions of that pod running. So if you think about, let's say, that Tailwind Traders order processing service, it's an order recommendation service. So let's say the recommendation service is busy and it's under heavy load. What we do is we spin up a second version of that, a second instance of that recommendation engine, and the queue can, there's those others can pull from the queue. And then maybe a third, maybe a fourth, maybe a fifth, and then scale back down that way. So this is actually scaling the pods, so different instances of your application pods on your node. So that's HPA. So, and that's based off metrics as well. So if you look at metrics, it could be potentially, the resource demand. If you find that the service is, one particular service is requiring more resources, it's like, okay, cool, I'm struggling here, I need more resources. Spins up another pod, which will take over some of that load. So this is not about the physical machines don't change here. It's just about creating different pod instances on a physical machine. So virtual node. Virtual node is also based off Virtual Kubelet, which is an open source project. I talked about it in the beginning, but yeah, it's the same as what I said a minute ago. It creates a virtual node. So you've got your 1, 2, 3, 4 physical nodes with the Kubernetes API. You've got one virtual node, virtual kubelet, and the kubelet is the node agent that runs, or the Kubernetes agent which runs on each pod, each node. And there's a virtual kubelet running which you can use to have this virtual node. So that's basically it. So virtual node works that way. So there's a few, when the virtual node registers itself as a node, it only deploys pods and containers that come from this Kubernetes service. Right, so virtual node supports Linux containers, Windows containers, and GPU. So in the backend, virtual node is using Helm to deploy the binary as it's needed to connect to ACI. So these are just virtual nodes support most type of workloads. Okay, so here's a gotcha. So if you create a Kubernetes cluster and you enable a virtual node, Kubernetes will not schedule pods to run on your virtual node by default. So by default, it won't. So what you need to do is when you create a YAML file where it has a deployment, so to deploy to Kubernetes, you use YAML files. So you specify, okay, a YAML file, this deployment will be this service and this service and this service, and these are the details of this service and the deployment of this service, right? So inside, when you deploy a new service, let's say it's this recommendations engine service, one of the pieces in the YAML file is the node selector. And node selector specifies which physical node or physical nodes or node pool this service can run on. Yeah, so let's say I have physical node 1, 2, 3, 4. I can specify here node selector that this service only runs on node 1 and 2 for some reason or other, because I don't know, some reason. Or I can specify that this service only runs on the virtual node. So if you don't specify a node selector, then the services will just run anywhere, but they will never run on the virtual node. So with the virtual node, you need to specifically say this service will run on the virtual node or not. So does that make sense? And here's an actual concrete example, right? So you're saying, okay, cool. This is actually saying Kubernetes, virtual kubelet. It's just saying, okay, so the node selector is this. So it's saying run on this. So you need to put this in. You need to specify the virtual node in the node selector. So if you spin up your cluster and you have lots of things running and you've got this virtual node, you go, cool, I thought it was infinite scale, but nothing's running on there. check that to see your deployments are specifying the node selector. There's plenty of documentation on node selectors. I'd say if it's a concept you're not familiar with, definitely read up on it. There's a concept of node pools. You can do selectors by groups. Okay, demos scaling with virtual node. I was going to give a demo on scaling using the virtual node, but there's I think I'm burning through time a bit. So what I'm going to do is I'm just going to quickly show the screen I'll just show you how easy it is to create a Kubernetes cluster through the UI with virtual nodes. So let me just jump here. Right, so let me, if I just want to add, so I'm in this resource group that I've got here. I want to add, let's say I want to add a Kubernetes service. Okay, so Kubernetes service, that's it. Okay, so I'm going to create a Kubernetes service. I'll give it a name here, call it tailwind test. Kubernetes version, so you need to specify the Kubernetes version that you're going to be using. Kubernetes changes all the time. It's always updating. There's new versions get released very, very often. So there's the preview version, there's the long-term support version, and versions that are no longer supported. So Kubernetes, the ecosystem is moving super fast right now. Be mindful of that. You specify your node size, how many nodes you want to be running. I've used too many. But you can specify how many nodes you want to run in your Kubernetes cluster. And I wanted to have a look at the piece on the virtual nodes, right? So you can just tick here to enable virtual nodes. And that's basically it, right? So here is how easy it is to turn on the virtual nodes. But do remember that you must do it at the time of creation. You can't enable it post the Kubernetes instance setup. And I've I've missed out on being able to use it before because I didn't set it up in the beginning, right? And had to redeploy a cluster. So that's that. I think, that's pretty much what I wanted to show you. I wanted to show you that the virtual nodes thing is here, and that the version thing and the node count. Right. So network and security. Introduction to AKS security. So this slide is, it looks very busy. It's a 30,000 foot overview. It shows this is all the networking and components the features, the security features that are offered in Azure. So there's security on the container registry, RBAC control. There's image and container level security. There's node and cluster level security. There's pod level security, like pod identity and security context. There's workload level security, so secure access on using the workloads and storage encryption, etc. There's a lot of security components that you could and probably should look at when you're building your AKS cluster. Right, so let me tell you about pod identity. So pod identity allows pods to connect to other Azure services securely. So basically it uses Active Directory to provide the pod with access to other Azure cloud services. So pod identity is also something that's unique to AKS. It's not part of the upstream Kubernetes, so it just comes with the AKS version. So when a pod needs access to other services like Cosmos DB, Key Vault, blob storage, whatever, the pod needs credentials, right? So these access credentials could be defined with the container image or injected as a Kubernetes secret, but they need to be manually created and assigned. So that's kind of like not so pretty, right? So pod identities is used for Azure resources, which lets you automatically request access to services through AD without defining on the pod itself the credentials, right? So when you define the pod in the YAML file, you can define run as user in the definition, but that's kind of very manual, and you don't want to have to do that, and change the user is going to be a problem, right? So pod identity gives the pod an identity, and Active Directory handles the sort of access granting to other services. I spoke a little bit about that in Key Vault, I think, in the first talk. Right, so pod identity, there's two components that handle the talking between Active Directory and Kubernetes. So one is node management identity, so it's a pod that runs as a daemon set. Daemon set is something that runs on each node in the cluster. And NMI listens for pod requests to Azure services. So each worker node has this little daemon set, this node management identity daemon set running inside it, and it listens for any requests to other services from the cluster. So cluster pod's like there, he's like, hey man, I need access to Cosmos DB. It's like, all right, this guy will go, okay, I'll get it for you. And the managed identity controller is a centralized pod with permissions to the Kubernetes API server, and it checks for an Azure identity that matches for that pod, right? So this network management identity goes like, hey man, I want to get access to this thing. The managed identity controller is the one that goes, okay, here. So the steps are here. So I'll just take a second to have a look at this. So the cluster operator first creates a service account that can be used to map identities when the pod requests access to services. Yep. Then the NMI server and MIC are deployed to relay any pod requests for access tokens to Active Directory. So it relays the request there. Then let's say a new pod is deployed with a managed identity, which requests an access token through the NMI server. And then the token's returned to the pod, and the pod uses that token to access a SQL server. I hope that makes sense. It's a little bit complicated, but that's sort of how it works. Okay, so on to network policy. Now, Azure provides two network policy options in AKS. You choose a network policy only when you create the cluster. So one of those gotchas, right? The policy option can't be changed. So these are the two network policy options. So there's Azure network policies and there's Calico network policies. So the main point to call out here for network people is that the Calico policies sets up kernel routes, like it uses kernel routes to route the network traffic, whereas Azure network policy filters the network traffic on the bridge. Now, the reason I'm talking about that is because it depends on the security audits that you might have to go through. So if you're going through some very heavy security audit for, your banking application, your super secure, application, you might not be allowed to do policy filtering on the bridge. So be very, very mindful of that when you start a Kubernetes project. Think about, hey, look, am I going to be audited in a way that you're working on some medical application, some personal data application? Do I need to filter at the kernel level, or do I filter on the bridge? Is that that's something. Both implementations just use IP tables, so they use IP tables to enforce it. They're just done in two different ways. So Calico, so obviously Azure is the Azure flavor, and Calico is one of the network plugins for Kubernetes, probably the most popular one for raw Kubernetes. Yeah. So here's a diagram. So here's Azure network policy. This is how it goes together. So we've got a logical set of pods there. We've got test and production, and we can see that both group of pods talk directly to the bridge. This is where the policy engine plugs in and enforces IP tables, preventing tests from talking to prod on the bridge. Yeah, you can see that the bridge connects to the VM network card, and it's protected by the network security group on the Azure physical network. So that's the summary of Azure network policy. Then Calico network policy, slightly different, right? So it does look kind of the same. For those who are not familiar with networking, it does look kind of the same. But in this one, we got test and prod as well. We can see that both pods use the network layer in the kernel to apply IP tables and layer 3 routing, right? So no packets leave the kernels and make their way to the bridge. So Calico plugs directly into the kernel, not into the bridge. So that's really, you don't even need to know the full details of how it works, really. I think just know that, that's the main separator, and have a think about that when you create your cluster. I'm going to skip straight to handling failures. So handling failures, how do you handle sort of failures in your Kubernetes cluster? So there's a concept of availability zones, which I talked about there, which it's high availability offering, which protects your applications from data center failures. Zones are in unique physical locations in the Azure region. So let's say in the Singapore region, there might be a data center in Jurong and then a data center in Changi Business Park. That would make up the Singapore region, but they're two different data centers, two different availability zones. So for some reason, if there's some fire in the data center in Jurong, then you're safe by having your servers running into different availability zones. So each zone, so they've got independent power, cooling, network. To ensure resiliency, there's a minimum of 3 separate zones in each enabled region. So all the regions that allow you to use availability zones, they all have at least 3 data centers in them. So some regions only have 2 data centers, and some regions have 3. So for any one where you can enable Kubernetes availability zones, they have at least 3. So these are the main features that availability zones give you: resiliency to data center failures. The nodes are split, so you've got that's a very, very common request from management. They're like, hey, what if this thing goes down? Is it gonna have we got high availability? So make sure you've got high availability because your nodes are split across different regions. You might not have to have the entire application running in one region. You might have it running across all 3 regions, but then just to know that if something happened in that region, it could continue to function using the other 2 regions. That's important to know. That's high availability, right? It also gives you something called fault domains. So there's a concept called fault domains, is where you can make sure that your software is running across multiple fault domains. So if there's a fault on this fault domain, which is usually a rack, it means that that rack, you're not limited to that rack. Right, so how do you do it? Yeah, so when you're designing Kubernetes, you want to consider availability zones. You should use your deployments with replicas set to the number of zones you're using. So when you've got 3 zones, when you use a deployment, make sure that it can deploy to all 3 zones. Make sure you use an ingress controller, which is highly available. So don't have one ingress controller. Make sure you have a highly available ingress controller. You can use either internal Kubernetes, or sometimes people I found use external load balancers, so that it's not within Kubernetes itself. So make sure your ingress controller is highly available. And understand that your disks mount in pods, right? So don't forget that if your application is running on a physical host, your one node, it will be the container will be using the storage on that host, right? Unless you specify it to use like Azure files or something. So if you shell into one of the containers and you sort of ls or whatever, it will just be in what's in the container, right? So what you should be doing is always mount a different file. Like if you want files to be resilient, you can mount like an Azure files folder into that container, so then at a specific path. So then when you go to that path is not really on the container, it's in the Azure files. So do have a think about that. So all the storage that needs to be resilient needs to be mounted storage, because if it's just using the storage in the container goes down, the data's gone, and then bad data day, right? Cool, so here's an example deployment. I talked about Kubernetes deployment way back at the beginning, but this is an example of what a full deployment looks like. So here we've got our web app deployment. It's got our selector. So selector is our node selector actually. So remember how I was saying that you need to specify what nodes you want to work on. So this is matches the web app label. So let's say I've got 5 nodes in my cluster and 3 of them can run the web app. I'm saying okay, make sure it deploys to one of the web app nodes. 3 replicas, making sure that at least there's 3 replicas of this pod running at any given time. If one goes down, it will spin up the 3rd one. If one, that's how Kubernetes works. If you delete one pod, it will automatically spin another one. Just some metadata and some details of the container there. Cool. That's about all I wanted to cover today. I know it's pretty heavy on the Kubernetes topics are pretty heavy. I was talking a lot. I will be available for Q&A. I think if you have any questions around this, feel free to ask me. There's a lot of topics there. Probably a lot of reading needs to be done, but hopefully I've given you a summary of Kubernetes at a high level and things to consider when you're building out your architecture with Kubernetes. Thanks very much, and look forward to seeing you in the next video. Hi, welcome back. Welcome back to Microsoft Azure Training Day, developing cloud-native applications. I'm Andrew Whiteside, your favorite speaker related to cloud native. I'm your man for helping you on this journey today. So we'll move straight into this topic. this one, we're going to be talking about taking your app to the next level with monitoring, performance, and scaling. So, these are very important things. I think, building your application, the architecture, having all those things in place is nice. But, once you have it in production, monitoring, performance, scaling, these are things you're going to have to look at. So, without further ado, let's get moving. Right, so let me tell you a little story, right? So this is Bob. He works at Tailwind Traders. He's a software developer, appreciator of fine sunglasses. So we're going to talk a little bit about Bob's kind of day, right? Right, okay, so Tailwind Traders is the application we've been referencing all day. It's a large sort of retail company with a network of stores, customers, big number of purchases actually happening in real time. They've also got deployments in different geographies with customers on a global scale. So Tailwind Traders is live. It's not just big retail outlets, it's kind of e-commerce that makes up the most of their revenue. So they've got their website, most of their revenue is made up from e-commerce. They're a modern company, having their thing deployed to production, that means production is their business, so they don't sell they don't have any physical stores, they just sell stuff online. Without the e-commerce side, they're dead. So availability, performance, uptime, it's kind of the livelihood of their business, right? So this the site looks like this. So they've recently rewritten the site in a new front end using React. They're also leveraging artificial intelligence to do kind of image recognition and allowing customers to kind of shop by photo. So one of the new features, it's a lot of cutting edge stuff in their application. You can upload a photo or share, and then based on the share, it would use AI to find similar chairs. So pretty elegant application. It's in production. Monitoring and availability is super important to them. Right, so we've seen the site, what it looks like. This is the kind of architecture that's behind it. They use React on the front. They've got Azure App Service on the back, a .NET Core application running in Azure App Service. So they've already migrated that to the cloud, which is cool. So that looks super clean. But the Kubernetes cluster that they've got, it's a bit of a mess. It's kind of got a database inside the cluster, a legacy database. It also contains the API that the website kind of interacts with, so you can see the website connecting to the Kubernetes cluster. All their data is in the Kubernetes cluster, and it's all hosted on AKs, right? So they have a lot of technologies mixed in, like most sort of apps that have been modernized over time. There's a lot of different technology pieces, so there's React in the front, .NET Core is the main sort of pieces, but they've got a little bit of Java, Node, some other JavaScript in there. They've got some SQL Server around, and it's all kind of like duct taped together inside the Kubernetes service. So that's because it could be a problem, right? So, and here's kind of my buddy Bob. So Bob's sort of on the hook of it all. So he's not the only developer in the company, but it's a pretty small company, Tailwind Traders. So if anything goes wrong and you just happen to be the closest developer walking past the person who notices what goes wrong, then you're the one who has to deal with it. So if you look closely into Bob's eyes, you can see he's had a couple of tough days, late nights. But Bob doesn't know today, but today's going to be one of those days. So this is Bob's problem, right? So Bob comes in like Monday morning, right? It's 9:30. He's just chilling. He's got to work. He just kind of goes to sit down in his chair, and then bang, the CIO of the company is sort of at his desk, right? So he's like, okay, what's going on? But he knows something bad, So the entire website's stopped functioning, right? So the boss comes down and says, hey, I just got a call from the CFO. Our site's processed 0 sales. If we had one less sale, we've been making negative products. He's pretty angry. He's like, fix it for the love of God. Just fix it while we all still have jobs making money. Then come to my office. I want to know exactly what happened. So Bob's like 9:30 in the morning. He's got a bit of a shock to the system, but he's got to sort of spring into action, So Bob's a little bit worried about this. So is everybody, right? So, and I'm sure you can empathize with this. If you've been an engineer working for a small company, surely things have been down, and people have been shouting, and you got to deal with it, right? So, how do you deal with it? You got to have tools. So, So Bob, don't worry, Bob's been through this before. He's had bad days, rough days. So he's come up with a plan. He's like, all right, this is the plan. I'm going to identify the issue, work out what it is, troubleshoot. So I dig in to find what the problem is, implement the fix, and then some measures to prevent it from happening again. So looking at this, finding out what the problem is often takes a part of the time. Troubleshooting, that probably takes the bulk of the time. Right? That's trying to find the issue, troubleshoot exactly what's causing the problem and how to remedy it. The fix is normally usually easy. When you find when you have this sort of critical issue, the whole site's gone down, the fix is usually easy. It's actually finding the problem that's the hard part. So the fix is normally like typo in connection string or a little bit of code that was wrong that was deployed. But getting the deployment out might be tricky depending on your environment. So he's going to identify, troubleshoot, fix, and come up with some prevention measures to stop it from happening again. Okay, so we're going to look at what tools he's going to work with. First is application insights. So that's Bob's first point of call. He wants to have a look at what's going wrong with this application. So application insights is part of Azure Monitor. So it's one of the pieces inside Azure Monitor. Azure Monitor is essentially an APM, an application monitoring service, which contains a suite of tools which allow you to monitor, troubleshoot, gain insights when it comes to your application. So application insights runs on the server and in the browser, providing insights to the front end, through the back end, and even sort of database. So application insights hooks into your application, and you can, based on application insights, you can have alerts, use Power BI, have a reporting to show you sort of what's happening with that application. It needs to be integrated with the application, so it gives you a whole bunch of different insights that you can, once you've integrated with your application, it gives you a whole bunch of insights related to the application, which you can use to troubleshoot and fix problems. So what exactly does it monitor? It monitors request rates, response times, failure rates, dependency rates, response times. Let's say with request rates and stuff, you can find out, which page is the most popular, what time of the day, who your users are, what browser they're using, see which pages have the best performance, worst performance. So you can use these insights to sort of bring in additional features to your application. You look at dependency rates, response times, failure rates, so you can find out what services are actually slowing you down. It also gives you exceptions, so you can see stack traces for requests. So if there's an exception, the application insights can get the log of the stack trace, and you can sort of dig in, see what line of code's giving you the problem. Both server and browser exceptions are reported to application insights, so you can get server-side and your browser-side ones, which is cool. Because actually in the past, I've always had different tools for server-side insights and browser-side insights. Browser-side exceptions and server-side exceptions. I've always in the past had different kind of reporting tools for it, but application insights allows you to sort of use one platform for both of those, which is kind of cool. It also logs the AJAX calls, so rates, response times, failures to do with AJAX calls, user and session counts. You've got performance counters from your actual physical machines. If you're one of those hardcore ops guys who's really looking at the physical machines, so you got your CPU, memory usage, etc. You've also got host diagnostics. So it's not mentioned here, but application insights also works for containers, so your container-based applications. So you can get the host, like the Docker host or the Azure host. You can get details of what's happening on that particular host machine, and also you get trace logs from your app, so you can manually log in, traces from your apps using a correlation ID or something, and you could look at that in application insights. So also there's custom metrics you can put in yourself. So from the UI, or you can actually build up. Okay, I want to get this metric based on a collection of drop downs you can choose. You could choose I want to see this metric at this time over this period, etc. So it's all time series based data. Okay, cool. Right, so now I'm going to do a demo on how to enable application insights in your application. So let me just go ahead and do that. Right, so let let's go have a look. So in order to enable application insights in your application, you actually need to have it registered with your application. So if you've worked with other sort of analytics tools, you need to register them with your application so that they can post data from your application to application insights. So here's an example. I'm showing you one example for the website, the Tailwind Traders website. So if you didn't remember here, we had the Tailwind Traders website here. So in order to enable for the application, what you need to do for a React application or a web application, you need to install two Node.js packages. One is for the web and one for React. Then once you've installed that dependency, you need to create a telemetry client class. So this is all boilerplate code. It comes with when you install the npm package. So it uses a React plugin for application insights. You note here that it uses an app insights instrumentation key. Then once you have that there, you need to put this code in the app.js for your React website. So it's just a little piece of code. It's also boilerplated code. You can see here that it also uses this config service application insights instrumentation key. Then this React application actually gets all its config from a .NET config service. So for this particular example, I can show you here, there's this .NET config service. It gets it from this settings URL. And inside this config service, it just has this, it responds with this application insights instrumentation key. So the main point is to get it into your application is just make sure that you install the Node.js package, have all the sort of wiring up there. There's plenty of documentation on how to do that. And then once it's all wired up, you'll need to grab your application insights key, which if you go to, if you already have set up application insights in Azure, you just go to the application insights instance. Here you see I've got one here. And then you can see the instrumentation key here. So you can take that. So once that instrumentation key is in, it'll be able to start tracking your website. So if you have a look at my example here on this website, you can have a look here. So we've got some bit here. Let's refresh this guy. So if you have a look at the network, you can see these track items here where it's pushing to application insights. Once you have application insights all set up, it gives you three sort of major components that you can look at related to your application. First of all, you get this application map, which shows you the way all the components of your application and how they kind of interact. So that's kind of cool. I'll drill into that a little bit later. One of the other pieces is smart detection. So one of the pieces that comes with application insights is a kind of smart detection where if you have something that's failing in your application sort of once in a while because of maybe internet connectivity issues or whatnot, then it's fine. But if it's something that's failing regularly, it will pop up here in this smart detection and it will recommend for you how to proceed and fix that kind of issue. Also, you get the live metrics. So this is live as in like live metrics, what's actually happening to your application now. So if you go here, like say I refresh this, this will be the last 60 seconds. It'll show like the actual requests coming in over a period of time. So this is pretty cool. So they're the bits that you get when it comes to application insights, and that's how you hook it up in your application. Okay, that was good. Then I'm going to give another demo on how to find and fix failures with failure analysis in application insights. Right, so remember we were talking about Bob, our buddy Bob, and he was told by his boss that, hey, the website's down. So just imagine you are Bob, step into the shoes of Bob for a minute. I know they're big shoes to fill, but try your best. So jump in here, he's come to work, he's looking, okay, Tailwind Traders website seems okay, it's loading. But let's click something here. Okay, let's refresh again. Okay, that's, seems like some kind of issues here. Yeah, there's definitely something wrong. Okay, Bob. Yeah, you got some issues. Okay, so now that he's found that there's an issue here, he wants to try and debug. So one of the things he would do is he would jump into application insights. For Bob, probably one of the first places you might want to look is the application map. Okay, well, let's have a look at the application map. Maybe we can see something wrong here. Okay, looking at the application map, you can see there's something here that's red. This shows all the interactions from within your application, but I can see that something over here, application insights, is connecting to. This looks weird. Okay, so if you found something red here, let's have a bit of a drill into what this is. So this actually shows the interactions between the applications. If you click on this, this will show, okay, cool, some status code is failing, so something's failing here. 12 of those failing there. Let's have a bit of an investigate. So you can drill down a little bit further and investigate the failures. So here it shows a little time graph of these are the failures that are happening at any given time. And you can actually see what endpoint is being hit when you fail. So it's starting to become a bit obvious to me what this problem might be. Let's have a click. You can also click onto this and you can see the details of this actual call. And when you drill down into the actual logs. So you've got this, you drill into the actual logs. Yep. Okay, I can see that it's calling, this is Ajax call, it's calling this get HTTP AKs backend endpoint. So looks like perhaps there's some kind of environment variable that hasn't been properly passed into the application. Okay, so let's say, okay, we are Bob, we've had a look, we found that this environment variable has not been passed into the application properly. This is the website, so obviously the website itself is not working, so there's some environment variable not being passed in the website. So let's go ahead and fix that. So I'm going to use just the Kubernetes console. If you're not familiar with Kubernetes, don't be worried, but I'll use this because this is kind of my tool of choice, I guess, when it comes to working with Kubernetes. So this is actually connected to my Azure instance, and kubectl is the command you use for executing commands against Kubernetes. So I know that So I know that there's some configuration files in the Kubernetes server. So for each specific pod that's running, there's a specific configuration file which is relevant to that pod which is running, and they're just YAML files which define some configuration values for that pod to run. So I know in the application there is this configuration file related to the web application. So I'll just use so kubectl is just your Kubernetes command line. Get CM is config map. So in Kubernetes world they're called config maps, and CM is just a kind of short form version of that. So you can very well say kubectl get config map. And what I want to do here is I want to edit this guy, kubectl edit. I'll make it config map just for verbosity, and this is the one I want to edit. And the way that I've set up my machine is that my default editor for Kubernetes is VS Code. So I was using vmit actually. So vim, and then let's go into here. We just want to edit this file. So you see how there's that value in there is wrong. It's got the AKS backend endpoint. We want to be able to correct that up. So let's just jump in here. So it'll open up by default. If you use the kubectl command, it'll open by default using Vim. So I've got a Vim editor here. So I just want to change this to this. So let's just keep going back here. That looks more correct. I probably wouldn't be doing this in production. I wouldn't recommend directly modifying production or production configuration values. It should really be done through a deployment. But I'm doing it just for example's sake. So that's it. I edited that file now. So it should say I've edited that file. Okay, so that file is now edited. I can just check that out. So what I can do is I'll just describe it to make sure my edit is there. So you can describe is just the view, so if you just want to cat out a file, you can use describe and edit if you want to edit. And when you do edit, it will edit in your default editor. So here I've got this URL, that URL, so that seems a bit more correct. What I want to do here is what I want to do here is I just want to restart that pod so that it'll pick up the new configuration values. So there's a pod running, it's using the website. The actual website itself is running inside a pod, and that pod is using that configuration map value. So I just want to restart this pod. And because I don't like restarting stuff, I just delete pods, and I rely on the magic of Kubernetes to bring me up a new pod. So here I know that pod exists. I know that the Kubernetes deployment is set to have one pod running. I know that if I delete the pod, it will just spin up a new one. So for me, I'm a bit brazen with the way that I work. I'd rather delete the pod than scale it down and scale it back up. So, but effectively it's the same thing. So if I get the pods again, you can see there should be that web pod should still be there, but it should have a different unique identifier attached to it. Right, so see how that's, the pod previously was that, and now it's this. Right, so that's all started again. Let's have a look at the website. If we refresh this. Bada bing, bada boom, it works. So, Bob, you've done good. Tailwind Trader's website seems to be functioning once again. So let's just get rid of this. Let's go back to the page. Sure, we've got all of our, plumbing. Yeah, seems to be working. Okay, looking good. Cool, so that's an example of how to find and fix failures with failure analysis in Application Insights. So let's just recap what I did. So I found that the website had a problem, went down here to the App Insights. So I went down here to App Insights. Inside here, I had a look at the application map. Inside the application map, found that issue that I had here where the calls are going wrong. Chose to investigate the failures, saw the failures, had a look at the details in the logs. From the logs, I realized that that was the issue. Went to Kubernetes, changed the config map, fixed it up, and restarted the container. So that's a demo on finding and fixing failures with failure analysis. Hope that makes Bob's life a little bit easier. Okay, so here's some docs, right? So if you want to read more about Application Insights, you can go to this URL here. There's pretty much all the documentation about how Application Insights works, and most importantly, how to integrate it with your application. So there's obviously different ways to integrate it if you're using like a Node.js application versus a Java application versus a .NET application. So in here, all the docs tell you how to integrate that application. It's pretty straightforward. So you just browse to this, have a look, and then go through the steps to integrate Application Insight with your application. So it provides plugins for a variety of different languages. You just need to go and hook them up. Okay, back to my buddy Bob. Bob's pretty happy. He's going, okay, cool. I've got application instrumentation information. So I've got the information about the app, what's happening with the application. I can monitor this application nicely, but what else does he need to do? So aside from monitoring the application, you look at Azure Monitor as a whole. So Azure Monitor captures telemetry from a variety of different sources. So you've got your application, your operating system, your Azure resources as well, your Azure subscription resources, tenant, and any sort of custom sources that you have. So all of these integrate with Azure Monitor. So Azure Monitor is it's the larger package. Application Insights is a piece of that, which we installed a moment ago. So the telemetry is stored in the metrics and logs, so it's centralized, fully managed, optimized for cost and performance. So there's metrics and logs stored in Azure Monitor. And with all that data in one place, so the best part about the beauty of it is that all your data is in one place, right? So with all that data sort of stored in one place, all your monitoring data, you can really get a lot of value adds, right? So first you can get the application insights, which we talked about a minute ago. So monitoring applications, monitoring applications, containers, VMs, networks. So you can get insights related to all of that. In addition, there's monitoring solutions for SQL and analytics. There's also gives you a lot of different visualization options where you can use dashboards, views, Power BI, and the alerts and the auto scaling. So don't forget auto scaling. So I was talking about Kubernetes and scale before. One of the important things is that you can, based on an insight, you can, analyze the new data that's coming on, and based on that new data, generate an alert, right? So let's say, you found that customers are getting mad on Fridays at 7 p.m., right? So then what's wrong here? Why is everybody, you get a lot of negative reviews, on Saturday mornings or whatever. So then you can dig into the data, go, okay, what's happening on Friday? You can say, Friday, there's a heavy load on this particular service. And okay, cool, I've analyzed that, I know that now, and then create an alert when that happens. Sure, but you can also scale it when that happens, right? So you could say, now that I know that people are cranking on Saturday morning because the application had some performance issues on Friday, I can say, look out for that performance issue and put in something, make sure that service scales when that happens. So it's really about having an end-to-end solution on how to solve any problems, right? So often you can monitor, but what's the point in monitoring unless you can do something about it, right? So you want to monitor, analyze that data based on as much data as you can get, come up with a solution, and implement, right? So that's the only way to prevent these problems from happening in the future, which is definitely what Bob wants. He doesn't want to be woken up on a Saturday morning. Right, so this is a quick demo on monitoring and fixing failures using Azure Monitor for containers. All right, I'll just go ahead and demo this now. You're back looking at the website, you notice, okay, cool, everything seems to be kind of working fine. You just have a bit of a click around, make sure that everything here is okay, seems okay. Maybe let's try buying stuff. Let's try buying a store. Ooh, looks like we got another problem here. Let's have a look. So here I'm actually looking at this is my Kubernetes service in Azure. So looking at the Kubernetes service, I want to come down to Insights here. And this is essentially this is Azure Monitor. The cool thing is this is super, super cool. So Azure Monitor actually gives you a whole bunch of different metrics. It gives you your full cluster metrics, so you can see there's the metrics for the CPU utilization across the different nodes in my cluster, memory utilization, the number of pods that are running on each node counts, how many I have, etc. So it gives you kind of a similar layout to what you would get with Prometheus. So if you're familiar with Prometheus and you're using sort of Kubernetes in your own kind of on-prem, or you know about Kubernetes running on-prem, a lot of people, when they run Kubernetes on-prem or in their own setup, they go with Prometheus as a kind of monitoring tool to monitor what's happening in Kubernetes. Now, over here, Azure Monitor, on the insights for your container or for your Kubernetes instance, gives you basically those exact same metrics out of the box, right? Without having to manage your own Prometheus and Grafana kind of virtual machines or servers or whatnot. So that's super, super cool. So you've got cluster metrics. You can go to your nodes. You can have a look at your nodes and see, okay, cool, those nodes are okay, seem to be functioning fine. There's 2 of them here. You can go down to the controllers, have a look at some of the data there. So don't forget, we're trying to dig. We're looking. Is there any issues here that Bob was trying to debug? So nothing. Cluster seems okay. Nodes seem okay. Yeah. Okay. Cool. Let's go down to containers. Any issues down here? So okay, these are all my containers. Seems to be all running fine. Oh, wait a minute. What's this? Got some kind of warning here. Let's have a look. So I can see all my containers have been up for 20 hours, but I can see this one down here. Oops, it's got a question mark on it. Okay, cool. So for me, looking at this, because I know Kubernetes, I know that crash loop back off is usually something bad. So you can actually have a look at the live data, which will drill into the logs of the container itself. If the container happens to be running, but I think it's been crashing. So you can actually also drill into the container logs in analytics. So let's have a look at log analytics. It will query the log analytics for the data related to that server. So let's have a look. Maybe we can get some information related to that container. Okay, this 127001 looks like it's probably not what it's supposed to be. So a similar kind of problem. Yeah, localhost 127. Okay, cool. So that looks like, I think I know what this problem is. So I'm going to fix this one up in Kubernetes as well. So again, I'll go to Kubernetes. One of the things I wanted to show in the last demo was that you can actually set, like, you notice how that when you use kubectl edit, it opens up in Vim. What I wanted to show that I don't really like to use Vim. I prefer to use VS Code as my default editor. So you can actually set VS Code to be your default editor for when you're doing your kubectl commands. So this is just setting it to be code, provided you've already set up VS Code before. So I'll show you how it looks like editing in code. So let's just do kubectl get pods. It'll list out my pods. Yeah. Right, so I can see that here's my one here. I can see that this guy's in an error state. He's been restarting for a long time. Now I want to just get the config maps because I want to edit the config map for that particular cart service because I know what's wrong. I think I've missed out putting the host file in there. So kubectl edit config map, this one. Cool. As promised, it's opened up in VS Code. So I think this is a little bit better. So this has opened up the file on the server in my VS Code instance here. And then when I save it and close it, it will push it back up. So here I just want to replace that host entry, which funnily enough, I also saved before. I'm prepared for this kind of, Bob is very prepared for this kind of situation. So that's that, save that. That will now push the edited file back up to the server. I want to have a look at the pods again. And if I wait for that crashing pod to restart, it will restart with the correct config. But what I'll do is, my favorite thing to do is just delete it. So if I delete it, it'll delete that one and will force up a new one. The thing with crash loop back off is that it actually crashes and it backs off in a loop. So it does it tries 10 seconds, 100 seconds, 1,000 seconds, etc. So it keeps restarting. Oh, whoops, sorry, I want to delete, not get. So that will delete my pod there. This I'm connected directly from my local machine over to the Kubernetes instance in Azure. So if you use the Azure portal, you find it a little bit faster. So that's just a pro tip. Right, so now my pod is running. Awesome, that's been running for 23 seconds, which is cool. If I come back here to my monitor stuff, insights, containers. Okay, it still shows warning, but it will after a moment. They'll come back together. So let me just double check my website now. If I add to cart, all right, that works. My cart service is back online. So fix that up in Kubernetes as well. Cool, so that was another demo on how you can use Azure Monitor to drill down and find problems. And just the fact that Azure Monitor is cool. Like, I think it's probably one of the best things that comes with Kubernetes. If you're working with Kubernetes, you definitely want to be able to monitor it and see what's going on. Right? So that was monitoring and fixing failures in AKS using Azure Monitor for containers. Hope that helped you out. Let's go back to the slide deck. Okay, so also there's docs here. So if you want to know more about Azure Monitor for Containers, please read up on the docs here. There's a lot of good information there about how it works, what kind of metrics you can and can't get. I think probably most of the stuff that you would want is there, but it's good to understand how it works and then what you can do with those logs. So I think they've also got some sample scenarios there of things that you might need to investigate when you're dealing with containers in a Kubernetes infrastructure. So yeah, Monitor will give you a lot of, if you read the docs, it'll give you a lot of tips on that. Right, so now we've talked about application insights as in how to get that information or work out what's going wrong. Azure Monitor as well to troubleshoot. And then here we've found all the issues, but we haven't really talked about how to prevent things from happening, right? So we identified the issue, we troubleshooted, we know the fixes, but we haven't really talked about prevention yet. So there are some steps that you can put in place to prevent things from going wrong. So one of the things that you can put in is called Azure Front Door. So Azure Front Door is a new service. What it does is it allows you to take traffic and route it to the closest region to your users. And automatically picks the right region for you. So think of it as kind of like a load balancer on steroids. So what it does is it pushes all your assets to a CDN closer to your users by default. So it does health checks, keeps an eye on your servers. You can allow SSL termination there. And if you see the diagram here, you've got this guy interacting with this edge location. Now, from Azure Front Door, it'll either route them to the cluster that's in East US or the cluster that's in Australia East. Now, you probably don't want someone who's living in Australia downloading all the assets from East US. They should be really downloading it from Australia because it's nearby. So Azure Front Door takes care of all that for you. Rather than just balancing the load, it works out where to send the user. So what else does it provide? Okay, traffic load balancing, does that CDN thing I talked about, and health checks. Again, it's a managed service with an interface that you can easily configure in the Azure Portal UI. I'll give you a quick demo on exactly what that is, Front Door, and I'll show you sort of how that works. So let's say I've got my application set up here, and I want to create a Front Door. So I've got a Front Door policy already, that's done, but I'll add one. So I want to add a Azure Front Door. So you add a front door like this. Right, I've got it here. I want to pop it wherever it lives. It's in the East US. Let's do the configuration. So I like this UI. This is really nice. So you actually configure what are the front ends or domains that are going to be used by front door. So you can say hostname, whatever, andrew.com, Andrew something. You can say you can choose if you want to have session affinity. So that means session affinity means that if one user accesses the site and it sends them to the East US cluster, then for subsequent requests, it will always send them to the East US cluster. That's what affinity is about. So you can enable that or disable that. And then you can also apply web application firewall policies. So let's say you want to, let's say everybody's coming into your application through this front door. You can say at the front door, okay, block DDoS attack. So you can do all your DDoS prevention at the at the front door rather than having to do it like many times in each of your clusters. So that's cool. So let's add that. Right, then backend pool. So you create a backend pool that that your front end host will connect to. So you jump here, the backend. Actually, in this case, it's something else. Test.com. Tests. Okay. Okay, the path, and you put in the probe method, load balancing. So these are the backends that you have. So these might be the Kubernetes clusters that you have running in the back. So you put those. What I need to do here? Missing this. Oh, sorry. Backend host type. Maybe it's so the backend host type is app servers. It's this website is the backend. Okay. Okay, it's done. Right, so I've got my backend pool here, and then you can set up routing rules. So routing rules might be call it test rule, and the front end there, and it'll say, okay, when it hits this one, redirect to forward to this backend for sure. So that's fine. And there you go. So that's basically a front door. Create it. It'll go off and create it, but that will take a little bit of time. Basically, that's the UI for creating a front door. It's like super simple. Just wanted to show that. Also, there's some docs on the front door service. So have a read about that. It will tell you like, okay, what are the benefits that you get using front door when you're, as opposed to just a standard load balancer. I think that if you have an application that's running in multiple regions, multiple clusters, and you have worldwide user base, then looking at a front door is probably the best solution. As always, as any sort of good architect will say, I always say it depends on your solution. If you've got something that sort of needs worldwide availability, then look into front door. It's a pretty cool product. Cool. So in this session, we talked a little bit about monitoring with application insights. We talked a little bit about Azure Monitor in detail, what that is. And then we used Azure Front Door to prevent issues from, that issue from happening again. Cool. That reaches the end of this talk on monitoring performance and scaling. It also reaches the end of this day of talks, the 5 sessions that I've been through today. Hopefully it gave you some insights into, how to develop cloud-native applications, and hopefully it helps you along your journey. That's pretty much what I want to do. I want to be able to help you guys, get on that cloud-native journey and help you with it. I mean, a lot of this stuff seems a little bit intimidating. I guess when you hear like Kubernetes, container, what's AKs, these terms, etc., it seems a little bit intimidating when all these tools are there and they're all around. You're not sure what they're for, but hopefully I've given you a little bit of understanding that, like, hey, there's all these things out there. You don't need to use everything. You just need to pick what's right for your application, and technically they're not that hard to use. So hopefully I've helped you with that, and hopefully you've enjoyed the session. Thank you very much for spending your time with me today, and enjoy your evening.